All right, here we
Hey,
go.
Buster, are you there? Have you got your guitar?
Okay. Is it a hump or a drop? What do you say? You got to twist your words in every which way, because the motto will always dictate what you do. Everybody knows that you've got the model affliction blues. Is it a straight line or does it curve? Some people unclamp it, but that is absurd. We all know that the model will always dictate what you do. Everybody knows that you are model afflicted blue. Model affliction. It's your addiction. That model affliction. It brings you so much pain. It's your ball and chain. Conflating curvature with elevation change has got your local distance just out of range. That old biggie is gonna dictate everything that you do. And everybody knows that you got the model affliction blue. It's your decision defending the model position. You just don't know the geometric proposition. That old ball, it'll always be illogical to you. That's why perpendicularity is a puzzle to you. Model affliction. It's your addiction. Model affliction. It brings you so much pain. It's your ball and chain.
World famous Buster. And we are live. Welcome, everyone. It's obviously Model Affliction Monday, and we've been going over. I don't know. I guess this is where everybody has to come to. People have been calling us flat earthers. We're not flat earthers. We just spotted these certain contradictions, but they go deeper than this model thing. There's a video on YouTube at the minute. I don't know whether we can go over it or not. Veritasium, if anybody knows, like, it's a pretty big guy, probably one of the ones that, well, he's got his information anyway, and he's gone over the sort of stuff that we've gone over. Now, hopefully we can go over it, but it's all about this geometry idea. The Paul says it as well, you know, like pick your geometry, as if you're forced to do that. Well, mathematics is sort of forced people into that position. There's a lot of stuff that people don't. There's people that say people don't understand mathematics. And I think that's because there's a certain branch of mathematics, modern day times, that can't be understood. There are no words to be able to describe it. And we've sort of fell into this realm of logic and reasoning, where this new mathematics and new logic and new geometry, modern geometry, frantic bunny ears, is it's undescribable. And that's why we've fell into this realm of trying to describe things without being able to have the words to be able to describe them. Now, I think we have, and I think I have the ability to be able to describe all of this model stuff, but it requires the listener or to sort of be on the same sort of wavelength within logic and to be able to access basic logic and reasoning abilities without having a bias towards a particular model. I think the model Affliction, which is what we go over here on these Monday nights, that's the barrier. There's people like Nathan Oakley and Dave Weiss and Jaron, and they call themselves flat earthers, and they've called themselves flat earthers, and that's their identity, the brand name. Oh, best put out there that Nathan Oakley, the campaign was successful. Nathan did get his hard drives fitted. He went there today. He's thanked everyone for their involvement and their help. So thank you if you did help Nathan. Nathan has sent us a thank you as well, because but I said I was going to help him put the thing out tonight. So if somebody has got the GoFundMe and one of the mods want to put it into the channel, because Nathan could still do with some more money. I mean, why not? He's got his hard drives fitted and he should be back up and running. I don't know whether he's going to give us word that he's got his setup sorted and he'll be back on tomorrow, or whether it's going to be a couple of days. Fingers crossed. He's got them fitted. He's back to his house and he's feverishly plugging wires in right now. So he'll be ready and in action back again tomorrow. There you go. Look at that. He's already got more than he needed, but I mean, Craig needs a bit of money as well. Can't let Craig do it for nothing. He's named his PB. Phoebe PC. So I haven't named my PC. So we get the link and we'll put it in the YouTube chat. Nathan's he has been thanking us on the in the Twitter. I mean, we did 10 hours. In that 10 hours that we did on Friday, I think he got £15. Now, I don't know if that was one of you guys. Thank you very much. If it was, even if you sent prayers and all of that, he didn't mention all of the prayers that were given. There we go. I'll just get that in the chat. everything or anything that anybody can do to help is will be a big help. Obviously, we don't want this sort of stuff going on happening again. We're no good at pushing the flat Earth stuff. They don't want us. Although we are a flat Earth friendly channel, Nathan Oakley, it's not really reciprocated through Nathan Oakley, but I mean that's all right. I mean it's only to be expected. I mean we do have a proof that the Earth's not flat, so it's understandable that Nathan Oakley, the flat earther, may be hostile towards us, but we're not like that over here. All YouTubers, all sorts of all our brothers, you know, like I mean that's how we get going, the conversation and through these things. Nathan Oakley, being a flat earther, requires a little bit of drama, so he has this thing where he, you know, he's nasty to people and he shouts and he calls women alcoholics, all of that sort of stuff. But I think that's just for drama, but I mean it could be real, could be. That's good. Geometry game. Spherical geometry, 10%. It's different than the we were watching. Who did we watch last night? Flatsoid. Flatsoid had a thing, and it seemed like the overriding thing within the audience was trollish in nature, let's say. Well, 81% there is Euclidean. That's more than I would be expecting, really. But I mean, I think our audience here is a little bit more knowledgeable because we've done this sort of stuff. I mean, how many people that are watching have watched the Veritasium video? I'll get that up in a minute. In fact, I'll get it now for you guys. This is, I'll put it in the chat. This is sort of what we've been working on. Don't leave us right now, but I would suggest that watching this and maybe handing it to people, you know, outside of this, is one of the trending videos on YouTube. So millions of people have got to see this. I think it's one of the things that we've been looking at. And if you haven't already seen it, what's going on? Why haven't you watched this? Trending on YouTube. It's a mathematics video, and you can see for yourself what modern society has developed mathematics into. Now, we started on this. I started on this particular looking at geometry because somebody called me a child abuser and then said that straight lines can curve within Euclidean geometry. Is it here? Do we have it on the soundboard? There we go.
In non-Euclidean geometry, straight lines can curve.
There you go. Straight lines can curve in non-Euclidean geometry. And that's what we're dealing with here. This is the farmer's boy.
It's both. It's both straight and curved. Both. At the same time. Yes, of course it is.
It's both straight and curved at the same time. So along with the pole, right? The pole goes spherical, hyperbolic, Euclidean, or all three. Well, you heard the dilithius farmer's boy there saying both straight and curved, which means you can't tell which way the curve is. Obviously, he didn't bother saying. So that could be spherical and hyperbolic, and the straight bit would be Euclidean. So farmer's boy, the dilithius, would go for all of them at the same time. the different geometries. I mean, but what does that mean? We went on a journey to first principles to understand the basics of what goes on within geometry, to understand that straight. I've had some really strange conversations about straight lines with grown men. Not many women. Not weird. I guess women don't really like talking about nonsense. Or maybe they do. I don't know. I've never really had that many conversations with women about this sort of stuff, but this video, I hope everybody's not gone to go and watch it. Much more interesting than what we're doing. This video goes over a few things, and I think it's a great study over, I don't know whether this would start about 1800s, I think it starts, which would be, you know, going along with the timeline of most of this stuff, of when they started messing around with things. Straight lines. See, mathematics, the shift changed in mathematics when they brought a zero in. And then you can go the opposite side of zero, right? So you've already gone into a fantasy realm within mathematics with the inclusion of zero. But beyond that, you have to, in order to destroy minds of people, to end up in the place that we are modern day times, you have to do much more than just trick people within number form. You have to take geometry and logic along with it. And the trick that the Veritasium video exposes, I think it exposes, but I'm less and less convinced that people can see contradictions modern day times. I think it seems that the education system has removed logic from the consciousness of people. The reasoning ability has been extracted through education somehow. And we're in the situation we are today. This video exposes how the breakdown of the logic started. And obviously it occurred through geometry first, through a certain group of people, a few individuals, and a few stories to go along with it. Well, the video I've just posted in there, that's done by Veritasium, exposes how modern mathematics works, because to my understanding, Veritasium is a YouTuber. I mean, yes, he does physics videos and all of this, but he just is just a YouTuber. He's not a mathematician, and he's not a physicist. He's not really done anything other than his YouTube videos. Pretty good YouTube videos, but he compiles all of his stuff together, and you can see in the video he has a list of all of the things where he's got these little bits of information from that he's compiled together, and probably AI to piece the bits together with a little bit of fancy narrative and pictures and stuff, and a few little stories. But there's a lot of the distraction and deflection, magic tricks, sleight of hand within the video that Veritasium seems to brush over. Like, there's quite a few times where they just cannot see contradictions. They make a point of saying that the people within the video cannot see contradictions. And we've been saying it for a bit. We've been saying the logic that we do and these arguments that we present, they can't be accessed by this group of people because they cannot access the logic. They can't see contradictions. And if you can't see contradictions, then you can't make a logical statement, because seeing the contradiction would disprove the statement. And that, to a certain group of people, is a little bit too much. They can't access these proofs that are available within this logical method that comes from geometry. The particular method we're talking about, Euclidean geometry, which most people in the chat seem to have decided to pick in the geometry game. But what is the geometry game? There is only reality. So the question is, if Euclidean geometry is the geometry that most people would pick in reality, what is the use of these other geometries? Where would they be used, and for what purpose? That's the bit that this video sort of exposes, but the trick's done right at the beginning. If you spot that, then you can see what's going on. The very first principles of the understanding of this geometry is based upon an axiomatic system. Well, they just tweak it a bit. Brenda told us about this. You can just make up your own axioms. And that's allowable modern day times. That's how we end up in these, in the situation that we are in. Where people are, let me get these, people are, there's two guys and they do most of the stuff in the morning. So we're always talking about what they do early in the morning. And when we get to do these live shows, this sort of stuff never really gets talked about in the live shows. But because we've been going over this, we've got the thumbnail for today's stream is a logical argument that Bob made. It's called a modus ponens. Nobody's ever even heard of it. Nobody's asked us about it. Nobody's ever attempted to rebut it, even though it's really simple to rebut. And that rebuttal, according to the way logic goes and the formulation of the structure that Bob's given us, you can falsify the globe model. So it doesn't seem like anybody's bothered, because I think they've already done it. I don't think there's anybody within this arena that can't already falsify the globe model. But the thing is that as easy as it is to make the argument into a modus tollens and rebut it, and nobody's bothered doing it. Nobody of the globe side has bothered to come and say, hey, Bob made a bit of a mistake there and he's exposed our model, and you can obviously take it down. Please don't think that Bob represents the globe. Well, nobody said that either, because nobody can defend the globe. Not even the people like Bob. They just come up with ridiculous things to, I don't know, to come up with what they've come up with. So I'll get you these statements. I don't know, I've been taking quite a few of these screenshots from this morning. Okay, so this one is something which I didn't know about. Now, if anybody's listening, like, obviously we've been going over this, call it celestial navigation. We've been dealing with it because they say latitude and longitude obviously a two-dimensional coordinate system, and there's a certain group of people that think latitude and longitude go on a ball, so therefore it becomes a two-dimensional thing, which it goes over in the Veritasium video. They're wanting to turn a plane into a sphere. They say it without a joke. So the way Fight the Flat Earth started with this, and other people have been saying not Euclidean geometry, non-Euclidean geometry. Well, that's what's necessary. It's required for you to formulate a model, a certain model. Since this is Model Affliction Monday, I'll let everybody know that my model, if you want to talk about it, is this geometric model. And I always, every time, use Euclidean geometry. I've never used spherical geometry, and I've never used hyperbolic geometry, because I live in reality, and the only geometry I could ever possibly use would be Euclidean. That's just the way it is. And I think that goes for everybody else, but we'll get there. So this is a guy called Beddy. He goes by EDBY263 on YouTube. So shout out Beddy. We call him the Globe Dogmatician, because he's not really a logician. He likes to pretend he is, but I suppose he's the best that they've got. So he says, I said that vertical, by definition, is the direction in which a plumb line hangs, which, I mean, everybody knows that. He says, not horizontal. Blimey. And that blimey word is it's a UK term used by Ponzi hairdressers. They normally finish their sentences with that. And then he says, the change in latitude, brackets, measured in degrees, is equal to the change in direction in which a plumb line hangs. So the vertical, by definition, is the direction in which a plumb line hangs. So what he's saying is the change in latitude measured in degrees is equal to vertical change. So vertical changes direction by the same angular measurement as you can measure to a light in the sky. I don't know if people are aware of this, that vertical changes direction, or whether this just happens within this Beddy's dogmatician thing. Because we did this. I've got a drawing. Let me get the
But from his statement, we can know that he's not talking about one direction, because he said, I said that vertical by definition is the direction. But later he says that it means every direction.
yeah.
So it means one direction is all directions, which is contradiction.
But that's sort of how you prove this dogmatic globe model, right? At least we've done that anyway. You prove it by showing the contradiction, and he's just shown it there, that he thinks measuring angles to lights in the sky can change the direction of vertical. It's fantastic. So measuring lights in the sky to Betty, the globe dogmatician, changes the direction of vertical. Directly proportional. They're related to each other somehow.
Yes, but this is, in that case, it is also example of circular reasoning, because if he is trying to prove that measuring angles to lights in the sky are based on, let's say, spherical model, so it means that in premise it is changing of direction of vertical. So if someone is going to conclusion that because of that we have verticals diverging, it means that someone is creating circular reasoning, because he starts from diverging verticals, and in conclusion he ends in diverging verticals, which creates circular reasoning, as I said.
Well, I thought he wasn't able to tell us what the reference was of this change of direction. It's an angular change of direction, but it's an angular change of direction of the vertical. So what is the angle reference to is the question.
To direction of vertical. And because it is changing, it means that in fact this angle to...
You can't have both lines of your angle both being vertical.
Yes, I agree. That's why it is nonsense.
That's why Betty couldn't answer what it was referenced to, what this change of angle. He couldn't tell us what it was referenced to because he doesn't know.
I think maybe he knows, but he cannot answer, because the only answer that could make sense would be that I assume, baby, assume that the Earth is a sphere. And that would be admitting that he is begging the question and creating circular reasoning. That's why I think that he cannot answer that, because it would be admitting that he is creating circular reasoning.
Well, we had a few of these this morning.
And he, of course, would expose himself as a fallacious logician.
Let's see what have we got here. Right, because you see this FE dogma. We were talking about obviously whenever you get into these conversations, they're both messing about in different directions. So you've got Betty talking about plumb lines being vertical and then some sort of a change. But like, as I said to him, you've got to, in order to imply a change, you've got to have it relative to something, right? The change has to differ. You can't have something remaining the same but pretending there's some sort of a change. So vertical's always vertical. So the change of the vertical, it can't really be a change if it changes from vertical to vertical. There's not much of a change in that sort of thing, is there? It's like Clark Kent going into the phone box and coming out as Clark Kent. It's the same fucking thing. He's not changed at all. It's the same thing. Except Betty wants to believe there's a different angle associated with these verticals when they change. But is there really an angle associated with vertical in relation to vertical?
It is in model, but it is very difficult to defend his position because we know that objects visually are dropping, for example. So if you have some light in your ceiling in your home and you go away from that and you are going horizontally, this light on your ceiling will drop. And you can measure angle, the difference in angle. And from that, we know that this is, I call it perspective drop, or drop due to perspective. So it is visual, and it is very well-known thing. So you don't need to prove that. But somehow, Baby is trying to say that this phenomenon, let's say, this change of an angle is somehow linked to sphericity of the Earth, because he was talking about latitude and therefore globe model or spherical model of the globe.
I don't think he doesn't. He's very careful with the way he words these things, right? You can't imply that. He just says the change in latitude. Well, that's just measuring an angle to a light in the sky. You can't imply a sphere through that. You are literally just measuring an angle. Now, he relates that 1 degree every 69 miles to a change in the vertical. He doesn't associate it with a change in angle to the light in the sky. He considers it a change in the vertical, which I would give you that if the vertical changed, then the angle would remain the same and not change.
Angle to what?
To the light in the sky.
Angle to what?
To the light in the sky. The angle. I mean, obviously, he's saying you take the angle from the vertical. Right? So you're measuring the angle not from a horizontal, not from the horizon upwards to the thing, as you would imagine with an elevation angle. But because he's relating it to the vertical, it must be in relation to the vertical. So the angle changes as you move, but he thinks it's the vertical that's changing.
Yes, it is for me non sequitur because you have in both cases, even if you are moving in their model on spherical surface of the Earth, as they say, so this drop of the light in the sky is connected to your movement away from the star, let's say. It doesn't matter if you are going in curved path or in straight line, the drop would be the same. So
yeah, but if you're imagining the tilt is within the vertical, would the angle change?
Yes, that's why it is not non sequitur, because he is trying to prove that, or maybe he's trying to prove that different angle to the light in the sky proves diverging verticals, and it is not. It cannot prove. So that's my point, because you have the same effect of the dropping of the star visually in both cases. If you are going horizontally in straight line or you are going along the curve, the drop of the star would occur in both cases. And if you have in both cases the same effect, it means that you cannot prove anything. So absolutely you cannot prove diverging verticals by measuring the angles to lights in the sky.
Well, I would say that if you're trying to imagine the vertical tilting, then there would be no change in angle difference. The angle would stay the same because the vertical would tilt in order to compensate for it. You can't say there's a change of 1 degree over 69 miles and then apply that change to the vertical.
Yes, but the problem is, I would say that the angle could not stay the same because even in their model, if we are going, if verticals are diverging, they are diverging with distance. So you cannot have diverging verticals at the same spot. So if you want to have in their model diverging vertical with 1 degree difference, you need to move 69 miles. And if you go with 69 miles with on straight line, you will have this drop to the light in the sky also. So, but on with diverging verticals, you will have more drop. That's the difference. And this is where I think their model fails because they don't account for that distance. So they are saying that, of course, yes, the light in the sky is in at different angle because verticals are diverging, but they don't account for this distance 69 miles. And this 69 miles is distance in straight line. So distance in straight line does not assume diverging verticals, but it gives you difference in angle. So they are ignoring distance, this 69 miles distance. That's their error, because they have to be correct, geometrically, let's say correct, they have to measure this 69 miles in straight line, then they can measure drop of 1 degree, and then because this vertical, they assume it is diverging 1 degree, so they have to add another 1 degree. So in 69 miles, in their model, the star should drop not 1 degree, but 2 degrees.
That's what I'm saying. Like, if they say that the vertical's tilting that 1 degree, then there would be no change in the angle. But there is a reported change in the angle, which Beddy wants to attribute to the vertical. But in order for the vertical to change and the angle to change, then, like you say, there has to be a double change, because he's trying to apply it at both ends. He's trying to, because the angle is actually measured from the horizontal, right, upwards. That's where the angle's measured. And obviously, if you travel along the horizontal and measure a 1 degree difference, it's just 1 degree change from A to B of a measured angle change. But that's where we get today, right? We're going on about Bob and the shortest distance, because that's what's up for stakes here. This straight line. It may not seem like it, but Veritasium will tell you, and other people, the choice of geometry really dictates how you imagine a straight line. And the people that have put all three may be going along with this Einsteinian Riemannian type thing where they're different. All of the straight lines are different in different places. So what we have here now is where do you imagine the straight is? Does it change in different masses? Are there things that change your perception of straight? And can that straight be imagined both on a circle, on a sphere, a circular path, a straight, great circle? Or can you imagine that straight being on like a Pringle? A concave type surface, but they call it hyperbolic, right? They like they like crochets really to explain it.
I would say that hyperbolic straight line and spherical straight line are the same. Only they curve in different direction according to the surface.
No, you're a lot more restricted and confined with spherical geometry, obviously, because it's a Euclidean sphere that you're dealing with. Whereas hyperbolic is exponentially expanding, but not expanding. You have to place that expansion within your mind to infinity. It's a very strange place. I mean, hyperbolic is much different than what people imagine spherical geometry to be. There's a couple of different non-Euclidean geometries other than the Euclidean. But either way of the non-Euclidean, you have to step out of what you understand Euclidean to be, right? You can't really have the Euclidean straight alongside this other straight, because that's a recipe for disaster. There's contradictions the moment you imply a curved straight along with an actual straight.
Yes, I can answer your question, because your question is if you can imagine. And my answer is no, you cannot imagine. Because if you can imagine something, you can draw it, for example, on piece of paper. And you cannot imagine that straight line is the same as curve, because you can't draw straight line on piece of paper and curved line on piece of paper, and they are different on the same piece of paper. And if you are naming them as the same, you are just not telling the truth, because they are obviously different. So you cannot imagine them being the same. It is unimaginable. You cannot imagine that. You cannot take a picture of that. Some people can say that they can. I would say that they are lying, or maybe then they are fantasizing. But you cannot imagine. You cannot take, even in your mind, you cannot take picture of straight line and curved line and seeing them in your mind as the same. It is impossible.
Have you actually seen any of this video? I might be able
Not yet.
Okay, right. I want to go over it, but there's a few of these little things that obviously we can get going. Look at, check this out. This is him explaining hyperbolic geometry, but that's like everywhere, not just on that little bit that he's got there. I always think it's amazing when they go to knitting to explain non-Euclidean plane, because
This is not plane. Sorry.
well, this is the hyperbolic geometry. They go to crochet to explain the hyperbolic plane, and you've seen a Poincare disc. Well, that's sort of the same thing. You've got to imagine both in the, and this is non-Euclidean, the geometry that they're dealing with.
I would reduce that to saying that you can see something that is obviously not a plane, and you can just name it a plane for some reason. But this is what they are doing.
Yeah, the magic trick is to show you this, but in the meantime, get you to imagine spherical geometry is non-Euclidean, right? They show you this crocheting and hyperbolic and do all of that, but really what they're trying to do is to get you to accept spherical as a non-Euclidean geometry. You know, like slip it in through the back door, like you don't notice it within mathematics. And I think obviously we've been dealing with this sort of lying through logic, because I consider geometry to be the purest form of logic, and the only undeniable logic that there is, because most stuff can be argued, or it used to be olden days. The only thing that couldn't really be argued was geometry, because it was part of an axiomatic proof system. These were the undeniable truths expressed within geometry of old. But since the new maths has taken over, and they want to try and convince people they don't know what they're talking about, that, you know, you don't understand mathematics, they come up with this, really. But what they're trying to tell you you don't understand is something so basic and so fundamental. It's really self-evident. So they've got to go the other way. They've got to do something to stop you believing or understanding, knowing that this self-evident truths are actually real. And here we are, 2023, modern day. People are trying to play tricks on the fundamentals of mathematics. And they're blatant tricks. It's just sophistry. Now, Veritasium isn't the one that's doing the sophistry. He's just dictating a story that's been given, handed down. But this video is how these stories develop into this modern day thing. Like 2 million people at least have watched this video. I'll put it on here, so just so you guys in Discord, if anybody wants to come into Discord, you can watch the video here. We might start going over some of the voice and all of that, but I don't want to show the video, so I will show some screenshots of it in the chat as we're going over it. But we will be going over the Veritasium thing. Let me get a few more of this stuff, because we went over this. So this is Fe Dogma, and he's right. This is this is the dogma, and this is perhaps one of the next to have the nutsacking occur. This is dangerous stuff to the mind, particularly if you have a model when you're dealing with this mathematical stuff. A lot of people have gone mad, and I'm not joking. This sort of stuff drives people mad because you're dealing with your internal logical structure for how you understand things, reality, right? Your processing, your reasoning ability. And the moment you allow in a contradiction to be accepted, then you're on the step to madness, which I think is why in modern day times there seems to be people that cannot see contradictions. There's a lot of these people. You'll know it because you'll point out a contradiction to them and they won't see it. They might get annoyed at you for doing it and tell you you're wrong and it's not a contradiction and it's okay anyway, and stop talking about it. I don't want to go over it. That's normally how you can tell. The question we've been asking over this past bit of time, particularly within this realm, is how do you communicate with people that cannot see contradictions? Because in conversing with people and understanding how you can get a point across and explaining your rhetoric, if you point out a contradiction to somebody, but they can't see it, what happens to the conversation? I don't know whether many people have dealt with that sort of stuff. You probably have, but not noticed or not known the reason why. Well, we deal in that sort of logic stuff, and it's become obvious that we can show people contradictions. This is 2023. This is modern day, and we've gone 200-300 years along the line of de-education. It's not re-education. It's literally making people not aware within the education process. It's been allowed people to accept the words of shadow giants rather than being able to reason things for themselves. And that's pretty apparent whenever you watch anything modern day times. So F.E. Dogma's fallen into this trap. Now what he does is completely model afflicted, as we just saw with Betty. He imagines that a change in angle to a light in the sky can equate to a change in direction of vertical for some reason. There's no link between those two things, but Betty's placed them and linked them together somehow. And because it's Betty's paralogism, he won't be able to come and talk to us about it. So it'll never get explained as to why Betty's saying this. And nobody will ever question Betty on it within, the dogmatic globe model arena, because they fear that asking him the question, he won't be able to answer it, or they won't be able to understand what he's saying when he does answer it, because it's probably incoherent nonsense. But they'll have to go along with it because their model dictates that. Well, F.E. Dogma is the dogmatician that leads all of this sort of stuff. I've often thought, I wonder why they do this, because it just sounds ridiculous. Well, he says, yes, Bev, I admit what is plainly obvious. When those 5 northeast arm elevations are plotted on an elevation profile, they curve up from the end station to the corner station. He says curve up on an elevator. Now, does anybody know what he's talking about? Can anybody guess what he's talking about? With an upwards curve on an elevation profile.
Yes, I know, but he's using a vague expression because I still don't know if this curve is concave or convex, because
It's curving up. He says curving up.
so that would be convex, I think.
Well, curving up from the center station, right? Do you know what it is he's talking about?
I think, but yes, I know that he's
right.
talking
So
about
you've got the corner station. Now the corner station is the corner where the two arms meet, right? And he's saying the arm, at least one of them, the northeast arm, curves up from the corner station. Curves up from the end station to the corner station.
Up. So
Up. Yeah.
But up means slope. But if you have curve,
No, curve up. No, not a slope up. Curve up.
so it doesn't make any sense for me, because if you have curved line and you are comparing to straight line, then it is curving up, and then after this middle point where the sagitta is the biggest, you are curving down. So that's the problem with curve. That curve is curving up and down. So I really don't know what he's talking about, really.
Yeah, we've got somebody in the chat refuting the flat earth. Pretty easy to do. Come on in if you think you can explain this upwards curve from the thing. You're welcome to come in and explain it. Not only to me. I'm pretty sure there's other people that would love to hear flat earth dogmas. Somebody, there you go. No contradictions. Upward curving straight lines of the LIGO. Come on in, refute flat earth.
That's why I ask if it is straight line, but you cannot have curve, because curve is changing direction. So it is changing. It can start up, but it will end curving down. So only if you have straight line and slope, with this straight line, you can say that this line is constantly going up, because straight line does not change direction, and curved line is changing direction. That's why, for me, it doesn't make any sense what Effie Dogma said.
Yeah, we've got I can't, you have me blocked. We've got refute flat earth blocked. Refute flat earth has never been in here, has it? Is that
I think it's
account?
Brenda.
Yeah, but has that account ever been blocked?
I've never seen that account before.
No, and do we have Brenda blocked? I don't think we do we? Oh, I can't. Oh, yeah, I remember. Brenda was trying to report the channel. If that is you, Brenda, then yeah, you can have a go at explaining FE dogmas from the YouTube chat. We can't risk you coming in here and reporting the channel for, I don't know, because you can't explain what FE dogma is talking about. Is that Brenda? Look, it's got pie on the thing. Some sort of a fetish for pie. We went over that thing with Brenda the other day, didn't we, in pie and blue marble science? That was hilarious. I thought pie changed. What do you think pie would be on a hyperbolic crocheting thing? I think, isn't that why we were... What do you think you got banned for then? Is that... It must be Brenda. Must be Brenda. What do you think you got banned for, Brenda? If it wasn't for telling everyone that you were going to report the channel for something. I can't imagine why else would have blocked Brenda. Can you remember, Emma?
I think it was just being its usual vile self, and yeah, it got angry.
It got angry and wanted to start reporting
Yeah.
Discord channels to try and get them shut down.
Not to mention calling the names. I just will not repeat what Brenda said lastly to you, so because I don't want to even repeat. So
Brenda
you can
can't
explain,
remember.
Yeah, you can explain the what FE dogma means about an upwards curve on. He says he's never said that the horizontal plane tangent to a level line curves upwards, but in this one here, he says. Then when those 5 northeast arm elevations are plotted on an elevation profile, they curve up. Yeah, LIGO is meant to be on a horizontal plane, isn't it? The entire structure is built upon a horizontal plane. At some point, somewhere, the plane that you call LIGO is built on a horizontal plane. One horizontal plane.
yes, but this point wouldn't be this corner station, maybe?
No. Blue Marbles decided it's somewhere like in the middle of, near the corner, near the opposite corner somewhere. It has to be because their numbers won't work out otherwise. Basically, the person who did LIGO has messed up the numbers, and they've made a tangent at 2 points, which is impossible on the plane, but FE dogma won't admit that he's messed up and put 2 tangent points on it. So we choose not to mention the plane, but I mean, it is a problem for him. We can figure it out, Brenda. LIGO is built upon a horizontal plane, and horizontal planes have no elevation change on an elevation profile. That's pretty obvious. But FE dogma says it curves upwards. This straightest thing in the universe, claimed by many people. FE dogma says it curves upwards on an elevation profile. So the elevation profile of the straight line that LIGO is built in, well, call it a horizontal plane because there's 2 arms, FE dogma thinks curves upwards. We've been saying this for quite a while. It's contradictory and sort of impossible. Yet, FE dogma can't explain it. He can just type it in YouTube text chat trolling sort of situations. Brenda says, can explain it. Why does the straight line plane that LIGO is in curve upwards according to FE dogma? Brenda, please go. We'll wait. The moment you type it out, I will let everybody know what Brenda's response to the fact that FE dogma has said that a plane curves upwards in elevation profile. I presume it's a horizontal curving upwards according to this elevation profile. Brenda will have done this sort of stuff within debate, or maybe Brenda's been doing a little bit of is this hyperbolic geometry, or is this spherical geometry, or would you still be in the realms of Euclidean geometry doing an elevation profile? It gets hard to tell nowadays because certain people have introduced this three-way geometry that sort of imaginates itself out of the Euclidean realm into something else that's a little bit different. Upwards curving straight lines when plotted on elevation profiles. Like we said, in elevation profiles, in all building structures or whatever, then all horizontals are always parallel. And since LIGO would be built upon a horizontal plane, then that would be parallel to the baseline within the elevation profile also. All horizontals are parallel, and obviously the upwards curving horizontal on an elevation profile does seem a little bit impossible. But we'll wait for Brenda to come up with how to explain the impossible. And Big Blue, look at this Big Blue coming in to help as well. Oh no, Brenda, if you've been blocked, you're not going to get unblocked. That's one of the rules we have here. We don't unblock people. I think it was you came in on a stock account, didn't you? Brenda had been banned initially for reporting the Discord channels, and then the second time was a re-emergence of Brenda on a different account, much like Blue Marble's doing the same. He has his Big Blue because I presume one of the mods have blocked him in the Discord for saying something. I don't know. Whatever. See you later, Brenda. Are you gone? Thank you very much. Interesting. With the Black Swan. Brenda's now took possession of QE's Black Swan. I don't know whether he got the picture as well involved in it or just the argument. Nathan Oakley wasn't too keen to keep hold of it. Too hard to explain. So, as we say, FE Dogma has said that if you plot the arm of LIGO on an elevation profile, remember it's straight, it curves upwards. The straight arm of LIGO, which has to be straight, it's a laser thing, he thinks it curves upwards. If anybody else wants to work that one out, just remember, this is their model dictates. The dogmatic globe model dictates that this upwards curve of a horizontal line, a straight line, must occur within elevation profiles. And that's not just the elevation profile of LIGO, it's the elevation profile of everything. Obviously, easily disproved by looking at any elevation profile in reality. It's very strange, but that's the way this dogmatic globe model works. And the reasoning behind this is what happens after what occurs when we're going to go over it now. This is why we've been dealing with geometry and logic to prepare people for this, because this is the ultimate what occurs or what has occurred in the past. Now, the video that we're going to go over is structured in a way to perpetuate this trick that's been occurring, right? So it may get a little bit repetitive and we might have to go over it many times, but I encourage everybody to, if you see part of a trick or something doesn't seem right, speak up, because this is how the tricks are done. Oh, welcome, Titan, everybody. We're going to go into this video now, right? This is a video from Veritasium in Discord. If you want to actually watch the video, come into Discord. It's on my live stream. Anybody in Discord can click onto the actual video and watch it. You guys, because it's Veritasium, I don't want to risk him, you know, like they do. These big channels get very whatever with their material, right? So this is a learning video, and we've been over this sort of stuff many times, over with it, the Euclid, the logic, in sort of preparation. I would say to people that people think we've been up against globers and flat earthers. Well, not really. We're here spotting contradictions and little tricks that have been played, and this is my this is why I'm here. This particular part, this is the mathematical curiosity that I had. Now, I would say, please be careful with this, because this is the depths of the mind and knowledge that we're dealing with here. Okay, you guys are in. Here we go. It won't take long, and I'll be pausing it. You'll hear why.
A single sentence in one of the oldest math books held the key to understanding our universe. Euclid's Elements has been published in more editions than any other book except the Bible. It was the go-to math text for over 2,000 years. But for all that time, mathematicians were skeptical of a single line, which seemed like a mistake.
Okay, so I would say the most perfect axiomatic system ever designed. This is the formulation of mathematics. They're talking about a mistake. We have been over this, and the reasons. I hope people, if you've listened to what we've gone over, that would probably put you a little bit ahead of most people that listen to this.
But did he say that before Euclid, people were wondering what straight line is?
He does go over that. He does say it a little bit in a bit. He's trying to impart that before Euclid, it was different.
Yeah, but this is not true.
Well, I know, yes.
Explicitly.
No.
This is just not true, because they knew, and in fact, Euclid was not inventor of straight line. He just defined it slightly different or in different words, but
Yeah,
the meaning was
put
the
the
same.
system together to put all of the knowledge known into an axiomatic system. But that axiomatic system probably was being formulated way before.
Yes, and
It wasn't
Plato, for
Euclid that
example.
just decided all of this sort of stuff.
Yes, but Plato, for example, knew what straight line is, and his straight line, let's say, Plato's straight line was the same as Euclid's straight line. There is no difference. So where is this wondering what straight line is before Euclid? They knew what it is.
Yeah.
It was always the same.
But the trick here is to say this one line within Euclid, there's problems with it. And I've always find this hilarious because when I first looked into this, this is the sort of stuff that I found. And it just didn't fit to me. You know, the stories that they're saying, it just didn't ring true, right? You've got Euclid and you've got the most perfect system of axiomatic truths that go together and they build upon all of these things. But for some reason, they think that there's something wrong within the axioms at the beginning, the self-evident truths. Hey, here we go. Listen to this.
Ultimately, some of the greatest math minds realized that Euclid wasn't wrong after all. But
okay, so he wasn't wrong after all. So there's nothing wrong. The greatest minds realized there wasn't anything wrong. We're going to be just dealt with contradiction upon contradiction here. It's like a spin cycle of contradictions. So there was a problem, but then they realized there was nothing wrong there. And now there's more to the story.
But there was more to the story. Slight tweaks to this line opened up strange new universes.
Did you go? Did you hear that?
Okay, so from what he said, I can understand that before Euclid, straight line was not settled as Euclidean straight line. Maybe it was different even. But Euclid's definition is not wrong. But from Euclid now there is progression into this state, previous state before Euclid, and that's all right. So Euclid is not wrong. He said, he didn't say that he was right. He said he was not wrong. So it means that Euclid gave definition, but it is not wrong. But before Euclid, it was something different, maybe. And now we have the same different thing, and that's all right. And of course, it is more perspective to that. So Euclid, it's only a historical, let's say, thing. This is what I understand from what he said.
Yeah, he said slight tweaks to this line opened up strange new universes. Now, this is where, when we've been dealing with logic and how you deal with logic, there becomes a part that if you allow inaccuracy, contradiction to go by without you noticing it, then you explode your logical system. And what that means is that anything can happen. You can make anything happen within the logic once you allow contradictions and stuff within it.
Yes, and this expression slight tweaks to this line, and this line is straight line. You cannot have any tweaks to this line, because if you have tweaks to the straight line, this line is no
Well,
longer
he's
straight.
talking about the line of the triangle axiom. What they're going to call the fifth, we call it the 12th axiom, or the 13th, you know, depending on which Euclid book you've got. But we're talking about the triangle axiom here, and the slight tweak to the triangle axiom, i.e. triangles have more or less than 180 degrees, causes new universes to occur, which means anything can happen. This is the exploding of the logical system. But it happens within the mind of the people that are searching for these things.
Yes, it means that when he's talking about universe, it is only universe of your mind. This is not reality, because reality would not change. So his universe is his own mind.
Opened up strange new universes out of nothing. Surprisingly, 80 years later, we've
Out of nothing.
Yes, you are
Strange
creator,
new
yeah.
universes out of nothing. He's literally saying, if you can explode your logical system by making tweaks to the axioms, then you can...
You are a god.
You do anything. Yeah, you are God. You've literally made new universes. But it, like Paper says, it's only in your mind. You don't actually make new universes. You can just imagine. And that's where we're living in now. We're living in 2023, modern day. Fantasy land within mathematics.
found out those strange new universes are core to understanding our own universe.
So he's sort of going along with it now. This is the build-up at the beginning. If you can understand the exploded minds of what I call madmen, then you can understand the universe that we're in. Well,
so reality.
No, this isn't the... They've changed universe to mean something other than reality, haven't they? Reality is reality. The universe is out there. It's massive. And you need to be able to do this to the mind in order to get there. You can't get there with Euclidean geometry. It's just not possible.
Okay, so if he's talking about our own universe, so he's referring already to the model.
Yeah.
So in that way, he just said that you cannot understand our universe, which is not real, because if you are using Euclidean geometry.
Yeah.
So it means that this model is impossible.
Yeah, this is the trick. He wants you to do hyperbolic to imagine universes, but that universe requires the place that you're on to be this dogmatic globe, right? It works backwards. Within the exploding of the logical system, you still have to formulate it as though there's some sort of structure there for it to be built upon. Because we're used to proving things within Euclidean framework. But this is the undoing of Euclid and the expanding of the mind internally. That's where we're at. This gets really bad for the mind. And like I say, I've said this a few times. If you have a model, a dogmatic globe model, please don't listen to us talking about this. Because you might have to attempt to justify it, and then you will end up like these madmen. That's what happens. You'll lose your logical structure of the mind. Just live in the contradictions that you've got. You don't need to know about this. This is only for people that are willing to have the conversation. If you try and do this on your own, you will likely go mad from this point trying to justify the model within this geometric structure. So let's
Around
play games.
300 BC, the Greek mathematician Euclid takes on a massive project to summarize all mathematics known at the time, to essentially create the one book that contains everything that everyone knows about mathematics. But that's no easy task. See, before Euclid, there was a bit of a problem with math.
Right, so before Euclid, there was a problem with math. Like, I'm not too sure what this is. I think they've done this to the Pythagoreans. Obviously, you've heard of Pythagoras. Well, they try and play the problem, the number problem, the square root of 2 number problem. Whereas I'm not too sure it is a problem because it's a geometric square root and only comes in with the unit. I'm pretty sure they knew about it. It's not a problem, really. Anything to say, Paper? Anybody other mathematicians? I know there's other mathematicians here, but with what we're dealing with here is core concepts of mathematics and probably more logic than mathematics. It's just understanding the first principles, really.
Yes, and some because mathematics was philosophers, let's say ancient philosophers were also interested in mathematics as a part of, let's say, philosophy. So they used mathematics and geometry, for example, to prove something in philosophy. And they were doing that, and Aristotle did that. So, but some philosophers were using math and numbers into not only philosophy, but also to religion, or some kind of Gnostic thinking, that you can go beyond. If you are going into mathematics and numbers, you are going into spirituality, sort of. And this part, yes, is questionable, but not mathematics itself. So there is no problem in Pythagorean mathematics or geometry or whatever.
Yeah, it got incorporated within Euclid's whatever. But I mean, if you want to put it in a time frame, right? You've got Pythagoras and Socrates, and then you sort of get into the Euclid was sort of around with Socrates, or, you know, when recanting stories from Plato, they recanted stories of Euclid, Socrates, and about that sort of time, you had the students of Socrates who are Plato and supposedly Plato's student Aristotle. So they're all about the similar sort of time frame. Socrates, Plato, Aristotle, Euclid. A little bit before was Pythagoras, but not too much before. Similar sort of time frame. You can imagine them all sort of walking around together in the robes, discussing stuff in the Colosseum. That's where I like to imagine them, but they probably weren't.
But there was no problem with mathematics at all. Some people, as I said, used mathematics in kind of religion things or whatever. It doesn't matter.
Socrates, as wrote in Plato's plays, right? The sophists were everywhere, right? There's plays wrote about the sophists. So there would be sophists within this mathematical realm as well. People trying to trick people and deceive people by using these geometric mathematical tricks. A bit like FE math does, right? Just playing tricks on each other.
But
whether
it
somebody
doesn't
wrote
affect
that down
mathematics.
as a problem or not. It's hard
Yeah,
to
it's
tell.
no problem.
Yeah.
It doesn't affect mathematics itself.
Yeah, the way this stuff is worded is it's as though they're attempting some sort of sophistry within mathematics. This Veritasium video. I know he's going off what has been told, but you know, you've got to use modern day. Look at it as though, you know, be skeptical of what people are telling you of what happened in the past.
People would prove things, but they would just be going around in circles. Why does a triangle have 180 degrees? Because if you take two parallel lines, yeah, but why do parallel lines exist? Oh, that's because you can make a square. Why does a square?
Right, so
No, sorry.
I know. This is one of the things that we have to get up, right? So this guy, this is the first inclusion of this guy into this thing, and it seems to be Veritasium's advisor within mathematics, and you know, he's trying to explain the circularness of a triangle. Right now, why does a triangle have 180 degrees? And then he says something to do with parallel lines, and then why parallel lines to the square, right? Kevin pointed this out. The triangle has 180 degrees because it fits within a semicircle. And the right angle will always fit within the semicircle. So the proof of the triangle having 180 degrees doesn't come from parallel lines. This is step one of the trick that this guy's playing, and he's doing it straight to a Veritasium.
Yes, so he is what he is doing, and this is not the first time when I can hear that some people are implying circular or just fallacious reasoning to the basis of our knowledge.
Yeah.
So this guy is saying literally that Euclidean principles are based on circular reasoning.
No, he was saying that before Euclid, this is how they did it. But that's not why triangles have 180 degrees. I mean, he's not even going through the understanding of why 360 for a circle. Like, why don't you just call it one?
Yes, but he said this guy said that people were trying to prove. If you can back him sometime, like 20 seconds, because he was talking about proofs.
Yeah, he's talking about they used to prove it like this, but the point I'm trying to get at here is they wouldn't have proved a triangle with parallel lines, whereas that's what this guy said. So he's already trying to bring in parallel lines where they're not necessary, right? In this place here, he should have a circle here. There should be a circle there, or a semicircle, not parallel lines.
So we have two issues here. So he is not telling the truth, at least, and he is saying that his explanation, what they were doing at that time,
before
in ancient times, was circular reasoning.
Yeah, we'll do it. We'll go over it again so we can.
Yeah.
Everything that everyone knows about mathematics. But that's no easy task. See, before Euclid, there was a bit of a problem with math.
People would prove things, but they would just be going around in circles. Why does a triangle have 180 degrees?
People would prove things, but they'd be going round in circles. Well, that's circular reasoning. It's not proof.
Yes. So this is what I would say. It is dishonesty. because he says, literally, he says that people before Euclid were trying to prove something in mathematics using circular reasoning.
Yeah.
And this is not true.
Well, no, he didn't say trying to. He said they would prove it.
They would.
Yeah, so they would prove things with circular reasoning, which isn't a proof. And I don't know what he understands about it, because you don't prove
And
it with
now
parallel lines either. That's
Yes,
like the
and he's
second
now-
deception.
Yes, and he is now making example, which is a not true example. This is wrong example. So he is making analogy or example, and he is making wrong example. So he is mistaken in two ways. First, he is implying circular reasoning, and he is giving false example. That's why I could say that this is dishonest. I cannot explain other way.
Degrees, because if you take two parallel lines, yeah, but why do parallel lines exist? Oh, that's because you can make a square. Why does a square exist? You have this infinite recursion of what the fundamental reason why something is true is.
That's just bad.
Yes, but
That's bad.
and he
It's kind of-
said that this is proving that something is true
Yeah, the triangles have 180
Supposedly,
degrees.
yeah.
Yeah.
because of parallel lines, and parallel lines are somehow proving squares or whatever.
Yeah.
Yeah, it is not.
And the square proves the triangle.
Yeah,
Like, that doesn't really make any sense. And if you imagine that's what mathematics was before Euclid, then I don't know. Like, I don't know what you're meant to think about proof nowadays or how it would be done. He's not helped you out anything mathematically in what he just said there at all. In fact, he's probably taken you back a few steps.
Like in the dictionary, every word is defined in terms of other words. So how do you get to ground truth? Euclid
Ground truth. Has anybody ever heard of that?
no, I don't know what means maybe basic truth, but what does it mean for
Yeah.
him?
Ground truth, foundational truth. I think you mentioned, Bevan, another word for ground. I mean, it's talking about these terms and definitions and then using a word that has multiple meanings without explaining it.
Yes,
So you don't
because-
know if ground means like bedrock truth, like, or
maybe
Bev said,
axiom,
yeah,
axiom,
or
maybe.
maybe.
Well, I
but,
said
but Bev,
first principles. This is, I think, it should be.
maybe it should
It's
be.
the
But it
self-evident
could be
truths, isn't it?
it could be ground like ground coffee.
Yeah.
Right? Like small, infinitesimal proof. I don't know. You don't know because he doesn't explain it.
And it's not really common parlance either, is it? Right? It's
No, never
you
heard of
have
ground
to,
truth.
You have to decide something and put it there in the place of this.
Yep.
How do
It's
you
not a
get
common-
to ground truth? Well, first off,
It's n-
you need to know what the fuck it is before you can get there, before you
Yep.
can even attempt to head in that direction. You need to
As
know
you
what
said,
it
it's-
is.
it's not a common notion, right? Which is a part of Euclid.
Yeah.
Common notions. Not there. Not with this guy apparently.
Yeah, he doesn't use first principles or any, they may be just things that we've gone over, but they seem to be the core. And when we did the Euclid course at the university, then all of those terms were used in that too. Like they never mentioned ground truth. I've never heard of this. But I mean, it may be well known within mathematics. Brenda might know much more about it than, I don't think I've said, I don't think any of the dogmatic globe guys can ever attempt to communicate about this sort of stuff because I don't think they have the rhetoric to be able to.
And maybe this ground, because if ground is Earth, and if Earth is a sphere, we
Yeah.
would have spherical truth, maybe.
That's
Like
where they're
spherical
heading,
geometry.
right? You've spotted the sophistry within it already, because this is model affliction. It's model affliction Monday, and this is what's occurring. They're taking Euclid and they're saying, we need not that, but they need to butter you up a little bit first. They need to, who's it? The magician that lays up a path for you to follow. There's part of that within this. This is advertising. They're trying to sell you something, and you're not really aware of what they're trying to sell you yet. It becomes more and more apparent, though.
How do you get to ground truth? Euclid used a solution that was pioneered by the Greeks. Let's just accept a few of the most simple, basic things as being true.
See, let's just accept them as being true. Well, no. They gain that position by being self-evident truths. They're axiomatic, easily understandable, and obviously true. It really should go without saying that these are the truths, and anyone can go along with it.
Yes, and these are not postulates. They are axioms and common notions, not postulates.
That's the trick. And they give you 5, which there's a lot more than that. A lot more.
These are our postulates. Then, based upon these postulates, we can prove theorems, one at a time, building up our math using logic. So that as long as those first statements are true, then everything else that follows from them must definitely be true. He had perfected the gold standard for rigorous mathematical proof that all modern math relies on. Euclid used this method when he...
You see that? All modern math relies on. This is the thing that all mathematics relies on. This becomes the first principles of mathematics, yet it has its own first principles in logic, the core understanding based on self-evident truths.
Yes, but first thing he did in this video, he misrepresented Euclid.
Yeah.
And then he said that this is also now, as in Euclid, now these are principles of modern mathematics. But he misrepresented Euclid because postulates are not basic things in Euclid. In Euclid, there are axioms, common notions, and definitions. They are first, not postulates.
Yeah,
Sorry,
well, I would say that the postulates are just what you're allowed to do with the pen or paper or scribing bits in dirt, or how you can do that sort of thing and what you're allowed to do. Whereas they don't explain that sort of stuff, and they're playing I'd say this is a sophistry game, right? They're laying up a magic trick so they can fool people around what they're doing. This postulate thing is part of the setup.
Yes, and for example, if in postulate you have that you can do something with straight line, so he first had to define what straight line is, and Euclid did it. So you have already defined things. And in modern mathematics, you can redefine things. And if you use different definition, so you have different postulate. You cannot have the same postulate with different definitions, because this postulate is about different thing. And he is saying that this is the same, because Euclid taught us how to do that. And this is complete misrepresentation what Euclid did.
Yeah, Saragaki brings up a good point as well in the chat, that not only are they self-evident truths, right, axioms, but they can be proved. as in anything in reality. They may be self-evident, but they're self-evident because you can prove them.
Yes, by contradiction, you can prove, you can make reductio ad absurdum.
Yeah.
It always works. So you can prove by contradictory disproof. So if you are trying to disprove axiom, for example, you will land in a contradiction or just absurd.
Here we go. We're only 2 minutes.
Published his 13-book series called The Elements, in which he proved 465 theorems covering almost all of mathematics known at the time, including geometry and number theory. And all these theorems...
It's interesting there. He added in number theory. That's something most people don't mention when they're dealing with Euclid. They talk about plane geometry. Well, it's much more than that. It's everything known on mathematics at the point where Euclid did. So he introduced all of the number theory, primes, there were exponentials, there was all sorts of stuff that he added in through number as well. Briefly touched over there, but he did say it.
depended on were some definitions, a few common notions, and 5 postulates.
We go right to book 1, and book 1 starts with definitions. You got to start somewhere. And the definition is: a point is that which has no part. A line is a breadthless length, and the ends of lines are points. By line, he really means a curve.
He means any line.
Mm-hmm. He just means
and
a
then
line.
He defines straight line.
Mm-hmm. But so this guy, where he says by line, he really means a curve. That's another lie.
Yeah, because he means any line. It means
it just means a line.
Straight.
Yeah. He's not got to straight, but he goes to straight. He doesn't say curve beforehand. If he would have done, you could have said that that's what he meant, but he didn't say curve. This guy said curve.
Yep.
I'll just put a picture of this guy, just so you know, by the guy that's telling you. I would say lie, but I mean, he's just trying to interpret Euclid for you. This is the guy in the video that's interpreting Euclid for you. Do you believe him? That's up to you. If you believe him, then Euclid meant a curve. But I mean, he didn't, because he didn't say it. Dishonest people.
And then it has some ends. A straight line is a line that lies evenly within the points on itself, and then so on and so forth. He's got 23 definitions, then he's got the 5 postulates.
It doesn't tell you within the definitions there is a definition of parallel lines. Parallel lines are that straight lines that lie within a plane and do never meet each other. Extended indefinitely, never meet. So they're defined as being straight lines within a plane. Parallel lines, that is, within the definitions. But, I mean, we'll just completely brush over that. Don't even mention it.
And correct me if I'm wrong, but an honest person would also mention that there are, in fact, translations that don't have the postulates and definitions laid out the way that he's discussed that they're laid out.
Yeah.
For example, we know the 5th postulate, we around here call the 5th postulate the 12th axiom. And there's a reason why we call it the 12th axiom, because there are translations of Euclid that call that particular thing that's written the 12th axiom.
Mm-hmm.
And there are 11 that come before it. So that's also a deception, because an honest person would say, well, this is to some translations. With some translations, Euclid is saying that this is an axiom, not a postulate.
Yeah, I would say that this is because of maybe some intention. Because why someone would change axiom into postulate? Because in the mathematical mind, you cannot change axiom because it is unthinkable. But you can change postulate. You can disprove postulate or prove it wrong or whatever, because it is only postulate.
He's talking about a slight tweak at the beginning, though. He's already gone over the slight tweak that helps him expand new universes.
For me, it means that they are trying now, by renaming axioms into postulates, they are trying to change postulates, but in fact, they are trying to change axioms. But not saying that. We are not changing axioms, we are changing only postulates. It is plausible. But in fact, they are changing axioms. I think that this is my conspiratory theory here.
There's one particular axiom, right, whenever you go through this, that they'll always miss out. And it is an axiom, right? It states, no two straight lines can enclose a space. Very simple, obvious, self-evident truth. It's an axiom. But by placing these 5 postulates, then that allows this group of people to completely miss that out. So it's there in the background, right? You can't get rid of them, like paper says. They're axioms. They're going to be there no matter what. But if you don't mention it, then the obvious problems that come later on can be just dismissed and brushed over. Like they're not there. There's no problem there because you don't know about it.
Or just renaming, because, you cannot go against axiom, but you can go against postulate. So if you just rename axiom into postulate, then you can go against postulate. It is no longer axiom because we named it a postulate.
Yeah, well, you've just disappeared all of the axioms that were there with it as well, haven't you?
Yeah.
It's a magic trick by making it into a 5 postulates, whereas in reality, there's like 12 axioms and 3 postulates. So there's 15 to start off with. But if you can trick people into thinking there's only 5, then what happened to the other 10?
The disappearing axioms.
Yeah.
Yeah.
That's a magic trick, but it's not a magic trick. It's just deceitful. And if you're wondering why you don't understand mathematics, it's because people don't tell you the whole story that makes it very simple. We've been saying it for quite a while. This is fundamental, first principles sort of stuff. It's not difficult. It's really easy if you think about it, in the fundamental sort of way. It should be simple. This should be the first basics of mathematics. This is where you start. Yeah, these guys are already messing about with the fundamentals. It's terrible to me, coming as somebody who's trying to learn this stuff. I'm learning it on my own account because this is just deceitful. You have to be able to see through all of this sort of stuff. If you don't, well, if perhaps somebody never points it out to you. I'd have never looked at this sort of stuff unless somebody called me a child abuser and then told me that straight lines can curve because of some non-Euclidean geometry. It sounded weird to me. I thought he was taking the piss. But turns out that this sort of stuff does really happen. There are people that are trying to convince you of really strange things. This is one of them.
The first 4 are simple. 1, if you have 2 points, you can draw a straight line between them. 2, if you have a straight line, you can extend it indefinitely. 3, given a center and a radius, you can draw a circle. And the 4th is that all right angles are equal to each other.
Right, there's a few little indiscrepancies he's got there. The circle can be drawn at any size. It particularly states that. The line, straight line, obviously. Straight line extended indefinitely and all right angles are equal. But the circle, the one he missed out, I don't know whether I've got mine book here, but it does say at any distance from the centre for the circle. And I think he does that purposely. I think Euclid was a very clever person, especially within this sort of axiomatic system. And he used every word he needed to, none more, none less. He used everything in. So every word that he used had a purpose. And if it's in there for a reason. Trick number, God knows how many coming up here now.
But postulate 5 gets the big guns.
Which is that if a straight line falling on 2 straight lines makes the interior angles on the same side less than 2 right angles, the 2 straight lines, if produced indefinitely, meet on that side on which are the angles less than the 2 right angles.
I'll get you a picture of this so you can see it. Right, this is for you guys in the chat. You notice that this is actually the real Euclid 12th axiom. We call it the triangle axiom because, as it states there, I don't know why they make such a narrow angle. It's terrible. It doesn't explain it really, but there's 3 lines there, obviously, and they meet at this point.
Does anybody, that's a good point, Bev. Does anyone in their translations of Euclid have a graphic provided of this potential axiom / postulate? And if so, does it look like that?
I don't think I have a...
I can't remember. I think I have no graph for that because it's too obvious, I think.
Yeah. There might be a plate somewhere hidden away in the thing, but I don't know.
Okay, thank you.
Yeah. But that is look how small that angle is. In order to get that across, it's hard to tell, isn't it? But that's a triangle. It's if a straight line falling on 2 straight lines. So there's 3 straight lines in that. It may sound a little bit weird, but listen to this guy now.
What the hell is he talking about? That's a postulate? Like, all of these are, half of a sentence, and they're all blatant.
No, it's an axiom. It's not a postulate. It's an axiom. Self-evident
and
truth.
He said that they are blatantly obvious. Yes,
Yeah.
That's why they are axioms.
All the others are blatantly obvious, he's saying. This is... I don't know whether this has been recorded and clipped and, who's done what. But, I mean, listen to his reaction upon hearing the triangle axiom.
That side, on which are the angles less than the 2 right angles.
What the hell is he talking about? That's a postulate? Like, all of these are, half of a sentence, and they're all blatantly obvious. And then comes 5 out of left field, and it's like an entire paragraph. What is he doing?
It's an entire paragraph. What is he doing? I mean, who's this guy?
And why he's surprised,
Yeah.
I don't know. I am happy that these axioms are so clear. So there is no doubt that if I understand what he's saying, I mean Euclid saying, I understand principles of geometry and mathematics and logic. So it makes me happy. This simplicity of the axioms makes me happy. And because I have a firm basic for further knowledge. And he's surprised. Why? Why it is not complicated?
I quite like it because it does make it clear, and you can sort of work through it. It's a logical progression that you can follow through. Although it's very basic, you can follow it and understand that that must occur every time. You can follow through to see the self-evidentness of this, and you can go, yeah, I can understand that. At no point would I ever have the reaction that guy just had. It's like, whoa, what's that? It's longer, it's got more words in it, and that just doesn't make any sense, other than they're trying to trick people into thinking something different for some weird reason. I don't know why. Well, I do, but...
This made mathematicians suspicious. It seemed like Euclid made a mistake.
Like it... What?
Yes, but it seemed, but it wasn't a mistake, because in fact his postulates are axioms are irrefutable till today.
Yeah, no mathematicians ever said that.
Yeah.
So, why they're pretending that mathematicians said that? That, yeah, oh, he must have made a mistake there. It's like, no, nobody's ever said that. Apart from these people that are trying to push a narrative, right? This is the same as people talking about surveyors, right? And not knowing what surveyors do. This is people talking about mathematicians. And he's got a popular YouTube channel. It's trending. Millions of people have watched this. I don't know whether they've seen it or not. You know, like whether they've seen the trick being played upon them or whether they've accepted it. But it seemed like mathematicians don't deal in seeming like mistakes. Especially not with axiomatic systems, anyway.
Greek philosopher Proclus thought postulate 5 ought even to be struck out of the postulates altogether, for it is a theorem.
Right, and this is another one of the bits. For it is a theorem. So, well, I suppose it is really, because it says if a straight line, and then those lines will meet. So it's structured as a theorem.
No, it is not. Because there is no proof. This is just a conditional statement. So if we have this, the consequence of having this is a conclusion or a consequence. He's not proving that, because in theorem or proof, you need to prove that this is consequence of that, because it is obvious consequence. That's why it is axiom. So it is not proven here. We have conditional statement. We have, if we have this line falling on two lines, then we have triangle, because they are not parallel. So
no, it doesn't say. It just says then they will meet on the side which has less than two right angles, right? There is a condition where they won't meet.
Yes.
So the
but,
triangle is being formed is a then, right? They will meet on the side which has less than 2 right angles.
Yes, but this is consequence of them being, let's say, not parallel, because if they have less angle than on other side, it means if they have unequal angles, the consequence will be that they will have this vertex, let's say, or apex.
Yeah, they will meet.
Yes, so this is consequence of uneven angles. And
Well, it's an if P then Q, but
yeah,
there is a no, not Q. Because there is a condition, there's one specific condition that wouldn't apply. And that is
Yes.
where both sides have the sum of 2 right angles.
yes,
Which is
but in-
all right angles are equal sort of thing. That, you know, like that's the one condition.
Yes, but he is in this axiom, he is talking about when the third line is falling on 2 straight lines which are not parallel.
It doesn't say they're not parallel though, does it? So it's up to you to be able to see the one condition. I think that's why Euclid left it in, because there is a reasoning process that you need to apply whenever you're reading this one statement, right? It's been placed in at the beginning to show that you're going to need to do a little bit of work for yourself in order to read what isn't wrote, right? So in actual effect, the enthymeme is the parallel, right? But it's not mentioned. Euclid placed the parallel as an enthymeme within the triangle axiom as the one condition that wouldn't support the statement that he's saying. But it's self-evident that you should be able to do that. Which is the whole point of what they're going to do in a minute, is get around that whole thing. So people never need to apply that reasoning on their own behalf.
Okay, let's listen.
Yeah.
But if it's a theorem, we should be able to prove it from the first 4 postulates, so that's what many people tried. Some, including Ptolemy and Proclus, believed they had succeeded, but they hadn't.
Right, so there's a question now that you should be able to prove that from the ones that come before it. I don't know why they say that. There's no reason that you should ever need to prove a self-evident truth using the ones that come before it. It just doesn't make any sense.
Yeah, and by the way, this Ptolemy and Proclus, they could use their own proofs, and in many examples they did. So, for example, some, let's say, theorems are explained differently. So some things, Proclus, for example, is proving in different way than Euclid. And it's okay. The same thing is with the straight line, for example, with definition. So Plato had different definition of straight line, but it doesn't mean that straight line is different in Plato's view. It's the same, but he used different, let's say, approach. But he proved, but he's saying about the same thing. And the same Proclus and Ptolemy, they could prove the same things in somehow different ways, but they proved the same thing. So it is not that they disproved Euclid. No, they proved the same thing in different way. because there are some different ways of proving the same thing.
Well,
You can, yeah,
you might say that, but I mean, one of the next sophistry tricks is, you know, this. I think this rolls upon itself, and it's just as confusing as the actual story, or even trying to communicate about it. You can get into the weeds.
We should be able to prove it.
See, we should be able to prove it. Why? I mean, we can.
If it's a theorem, I think we have to keep in mind,
Yeah.
to be fair, right, that he's saying that some people thought it was a theorem, and if you treat it like a theorem, then it does need to be proven. No?
Yeah, well, I would. That's what I'd say, and I'd say, yes, it can be proven.
yeah,
But
still-
that's the point that's missing, right? Hang on, paper. That's the point that's missing here, is even an axiom can be proven. And this guy's acting like an axiom, or to his point, the postulates don't have to be proven.
Yeah,
Well, they may
he's
not
trying
have to
say-
be proven, but they can be.
He's trying to say that you have to be able to prove it, and then, for some reason, I don't know why you would have to be able to prove it, but because it's a self-evident truth and it's within this, of course it can be proved. But he passes over that as well. Like, it's as though nobody can prove it, which I think's a lie.
But he said that this is not theorem because some mathematicians considered this as not postulate, but a theorem. Therefore, it has to be proven.
Yeah.
So this is his line of, let's say, reasoning, or rather,
Yes.
rather deceiving people.
Yeah.
Agreed. Yep.
Because other people have said you could just put Pythagorean theorem, postulate, proposition 47 in the place of it, and it would make no difference.
Yeah. And it's
So,
called theorem, but in fact it is an axiom.
Yeah, you can prove it still. You can prove proposition 47. And you could put proposition 47 in the place of this thing. It's the same thing, and it's also provable. So, like, for why they think it's not provable, and for some reason why you'd have to prove it. So this next bit now, where they pretend that there's mathematicians out there that were flummoxed as to why Euclid wrote this thing that doesn't seem to fit and how they can't prove it. I mean, mathematicians aren't that stupid. They're trying to talk around it, to talk about something else without actually saying it.
Bit from the first 4 postulates, so that's what many people tried. Some, including Ptolemy and Proclus, believed they had succeeded, but they hadn't. In fact, all they'd managed to do was just restate postulate 5 in different words. Here's one formulation.
So how is this trying to prove it, where their end outcome is them just saying it in different words? I mean, that's not a proof, and that's not even an attempted proof. It's just an attempted rewording of the same
Rewording
thing.
of an axiom.
Yeah.
Because several of those are stuff that we've said here, like the last one there on the bottom. The sum of the angles in every triangle is 180 degrees.
Yeah.
Yeah.
But the reason Euclid did it was to talk about 3 lines, right? He's talking about the lines and their relationship to each other, and one truth about a reoccurring relationship about 2 of the angles. That's it. So it's more about, you know, how you can use a triangle within this system. And there's enthymemes hidden in it, the way he said it, that are there for you to discover. These take all of that away.
Yes,
They
and
take the beauty of it away, and the reasoning that you can do on your own.
he's bringing up here, we can see it in the paused clip. For example, the sum of the angles in every triangle is 180 degrees. And on the in the upper corner, the sum of the angles is the same for every triangle because it is 180 degrees. So you cannot have 180 degrees in various ways. There is only way to have 180 degrees. So they are using the same different words, but they are talking about exactly the same thing. So it is not even a changing definition, I would say. This is just the same thing in different words. Okay.
Yeah, it's not a proof. He said that they were trying to prove it. And this, in no way, is ever going to be classed as an attempt as a proof for an axiom or postulate, right?
Yes.
He's misrepresenting the mathematicians in his portrayal of what he said that they were doing.
Yes, and he's giving quotations here on the screen.
Yeah.
And none of them is a proof for anything.
Yeah, it's not even an attempt for a proof of anything.
Absolutely.
It's ridiculous.
Just rewarding the statement.
So again, you're not going to gain anything by listening to this guy and thinking this is how mathematicians come up with proofs. But hey, you're probably going to have to deal with this sort of discussion if you're going to talk to people. Because if you ever go to geometry, the people that you're talking to will tell you to watch this video. Guaranteed. They don't know what it means. And they'll expect you to gain what they got from this video. But I don't know what they've got from it so far. There seems to be a lot of deception going on and a lot of misrepresentation of both Euclid and mathematicians in the past.
If you have a line and a point that is not on that line, then there is a single unique line which will be parallel to the first line.
Right, now that is the big trick, right? Because you will never hear the traditional Euclid triangle axiom ever again. The Euclid one uses a straight line and two other lines crossing it, i.e. 3 lines, and it tells you where the triangle will be formed. And this is now talking about a line and a point, not what Euclid stated in the original statement. So they've just reworded the original statement.
For this reason, the fifth postulate is often called the parallel postulate.
So for this reason, so they've completely taken it away from being a triangle is formed, and they've now turned it into the one condition, the enthymeme, that was stated in the original thing, the thing that wasn't said. They've turned it into that. The thing that wasn't said in the original has now become the thing that they've turned it into.
Yes.
Yes, so I would say that this, what it is now called parallel postulate in Euclid, is just black swan, because there is only one example where when we can have this lines being parallel, it means they are on both sides of falling line equal angles.
But they've took away the line.
They took away the line, right?
Yes, I know.
That you have those right angles on. So now you're not associating it with any of the previous points.
Yeah, I agree.
And remember, that as you said, pointed out, Bev, they didn't mention the definition of parallel. So that's important here, right? This is if you just watch this and you haven't gone through Euclid, then and you haven't seen those other definitions, then this is the first time you're approached with parallel.
Yeah, the enthymeme, the thing that wasn't stated in the original thing, has now turned into the thing that they're calling the parallel postulate. And they're not mentioning, as Kev says, they're not mentioning the actual definition of parallel lines.
Which you'd think you'd want,
Yeah.
right? You'd want, if you were honest, you'd want to state, here's how Euclid defines parallel and what that actually means. But they don't say that, and you'll see a little bit later, there's a reason why they don't refer to the definitions. You'll see it in a few minutes.
Yeah.
Maybe 2 hours for us.
When the method of direct proof failed, other mathematicians, including Alhazen.
See, when the method of direct proof failed, well,
There was no proof.
there's no proof. They've
Rewording
just
of
changed.
definition.
Yeah, they've reworded the very axiom that they started with. That's where they've got to. Now, they've never even attempted a proof.
Atham and Omar Khayyam tried a different approach, proof by contradiction. The idea is simple. You keep the first 4 postulates the same, but assume that the 5th postulate is false.
We call this proof by contradiction. And
Yes,
if you
and-
know anything about what we've been doing, I'd say this is the simultaneous below. That's what we're setting up. The proof by contradiction, you end up with an absurdity.
Yes, and this is how you can prove axioms,
Yes.
not postulates.
Yeah.
Not okay, not necessarily postulate, because I agree you can prove, and Euclid did that many times. He proved postulates and theorems using reductio ad
Direct proof.
absurdum.
Yeah.
This is okay, but this is the only way how you can prove axioms.
Yeah.
So, but not postulates. Postulates are different things. You can prove it positively or negatively. But he is saying that this is only way to prove postulates.
They
it refers-
tried a different way,
They
right?
tried.
This is like these guys, not Euclid, right? Because although Euclid did do this, they're trying to
Yeah.
say that these other guys have tried to check Euclid's stuff and prove it by contradiction, which is the triangle axiom, right? They all were, it said that all of these
Yeah.
other people with triangles have 180, and like all sorts of different ways of saying it. So they're trying to say you can't prove positively that triangles have 180 degrees. Well, I think the proof that there is one place where no triangle would be formed would be the proof that the triangle needs and requires 180 degrees within the internal structure to be able to be formed. It's obvious. There's a positive proof for that. And the positive proof is that the parallel lines are formed and there's a place where no triangle is formed on either side of the line.
Yeah.
Is the proof.
Because they will, it is in the statement, because it states that they will never meet. And
Yeah.
in order to have triangle, they have to meet.
Yeah. And if you've
So-
got 2 right angles on both sides, then
Yes,
you can't form that triangle by the very axiom, by the statements within it. It just seems ridiculous to me that these, they're trying to pretend that people can't prove it, right? But now they're going to say, well, they couldn't prove it positively, so let's have a do it proving by contradiction, which is obviously a different type of proof, but it's well, listen to what they say.
Then you use those new postulates to prove theorems. And if that leads to a contradiction, for example, true equals false, well then...
If that leads to a contradiction, for instance, simultaneous below, where both ends of the line are below the other point at the other end, right? Then there's your contradiction. It can't be true, so therefore you've proved it false. Your direct assumption that it was false has led to a contradiction, proving that the false must be false. It's a double negative. Positive. The original theorem must be true.
Yep.
Then it means your new fifth postulate must be wrong. Therefore, the only remaining option would be that Euclid's version of the fifth postulate is correct, and you would have proven the fifth postulate. So, what would it look like if the fifth postulate were false? Well, according to Euclid, through a point not on a line, there could only be one line that is parallel to...
That's not according to Euclid.
Lying
Again.
bastard. That's not what Euclid
Not
said.
according to
You've
Euclid.
just fucking
Nope.
changed it. Yeah.
Yep.
Yes. So
While
he's-
showing it.
Yeah.
Sorry, Paper.
No, he's another time because he made this many times here in this short clip. So he's constantly misrepresenting Euclid first, and then he's using his misrepresentation of Euclid as Euclid source. He's using this as a source. This is what Euclid said, but he, of course, didn't say that. And now he's trying to disprove or question this not Euclid's argument, let's say. As
Right there.
Euclid's argument.
Yep. Right where Bev has it right now. That's, yes, those words are the fifth postulate / 12th axiom. That is correct. But then his voiceover does not say those words that are in red text there.
Yeah, he says, well,
it says according to Euclid.
And then he goes into the one that
Something
Euclid
else.
didn't fucking say.
We can see that if a straight line falling on two straight lines, and there is no three straight lines in his drawing.
Yeah, it doesn't mention parallel lines or a point. Like what he's about to say in this is not what Euclid said, right? So this is according to Euclid, but listen to where he's saying it. Like, if you weren't open to this and you'd never seen this before, you know, like, you could easily be deceived by this guy lying like he is about to.
Euclid, through a point not on a line, there could only be one line that is parallel to the first.
Lie. Euclid didn't say that, and not according to Euclid. According
By
to
the way,
somebody else's
you are clipping that.
interpretation of it.
I think you are clipping. It means slightly roboting, but I don't
the
know
video.
if it is only my issue or...
No, the video's fine. You're clipping a little bit.
Okay. Looks okay in. Do you want me to leave? Should I be coming out and coming back? What's it sound like in the...
I don't know if it's just us in
YouTube's-
Discord or if it's sounding that way in
Does it
YouTube.
sound all right in YouTube? Am I still clipping in Discord?
Yeah.
Yeah, okay, well, I'll just jump out of Discord. I'll be back in.
Oh my god!
There you go.
Oh Christ! Yeah, true level, bitch.
Let me get the screen back up. There you go. Is that better?
Yeah, you're all good.
Normal.
Yeah. Okay, jolly good. Yeah, it must have been Discord just has this thing every now and again. Once you've been in for a bit too long, out and in, sorts it out. Okay, so one parallel line. No, that's not what they're doing. It doesn't even mention parallel apart from in the definitions. And Euclid very cleverly doesn't use parallels where he could have easily used parallels, particularly in the Bridge of Asses postulate proposition 5 but 1. He could use parallels, but he doesn't. He doesn't need to, because it's self-evident, the truth, right? The enthymeme of the parallel is left up to you because you don't need it within the thing, but they're acting as though it's a big thing for Euclid. It just wasn't. This is already defined within the definitions.
One alternative is that there are no parallel lines that you could draw through that point.
Right, now, this is an alternative to parallel lines, obviously. But and particularly take note to this and see what you guys can gain from this.
Well, people tried that, and they realized that then lines had to be finite in length. And they're like, well, that can't be.
So this option was ruled out.
Right, okay. Did you see what he said?
Yep. You might want to play that again, because this is going to be very important in a few minutes. Really get
Euclid,
this understood.
Through a point not on a line, there could only be one line that is parallel to the first. One alternative is that there are no parallel lines that you...
Right, so no, this is an alternative. There are no parallel lines, but listen to why. Or
why?
The solution, the conclusion, or, like the reasoning behind what he says here.
Mm-hmm.
You could draw through that point.
Well, people tried that, and they realized that then lines had to be finite in length.
Thin lines had to be finite in length.
Yep. And you can't have that.
What does that mean?
And for me, it is the completely non sequitur. But because why? What length of the line, or being finite or infinite, how it is related to being parallel or not parallel? Because there is no link for me, at least.
Yeah. It's that closed caption is wrong. It's not thin. It's then. He's saying then.
Yeah. Do you reckon?
Yeah.
And they realized
for sure.
that then lines had to be...
Oh, then lines. Yeah, okay.
Yeah, lines had to be finite in length. That is important.
Yeah.
Because that is another axiom, right? Or the postulate.
For the fact of no parallel lines, they realized that lines had to be finite in length.
And they can't be.
They
can be extended indefinitely.
Yeah. And
so it would break the other postulate.
Why can't they be finite in length? Why can't these lines, for no parallel lines, be finite in length?
Because it says extended indefinitely.
Yeah.
In the actual text.
Yes.
Produced indefinitely.
Within the postulates that they're going with.
I think the trick is, because if you have a section of a straight line, finite section, you cannot say if this line is parallel or not, because you have no way because there is no extension of that line. So you cannot say if this line will meet with the other line, because you have only section. But if you have infinite line, there would be always a point that they will meet if they are not parallel. So you can show this point even on graph.
What you're missing here, Paper, is the fact that if they are finite, no matter how finite, doesn't matter, they can be extended indefinitely, so they can make them infinite just by the fact that they are finite to start off with, and you can't have that. That's what he's saying.
Yeah,
you've heard it before.
So it makes this example impossible. And by the way, I don't know why he's showing on the right side of his picture this parallel line, and then this line disappears because it cannot be. And my question is, why this line cannot be on other side of his picture? Why he's saying that zero parallel lines? Why this line has to disappear? because the other option is that there are no parallel lines, 0 parallel lines, and there is only point in his drawing and no line. And my question is why this is an option. Why this is an option here? That there are no 0 parallel lines. Why? Yes, this picture. Why? Why this line, this one parallel line disappears? This is my question. Why?
Because it can't be. For them to have 0 parallel lines, if you make this point anything more than a point, then you can make it an infinite line, and there would obviously be a parallel line to it.
Yeah.
That's what happens. Now, have you ever heard of anybody else wanting to get rid of a line?
Yes, reducing line to a point. Yes, this horizontal line. Yeah.
Right. So we do know people within this arena that also want to do this very thing. Now, they also might want to get rid of parallel lines for some reason, because we've made an argument about horizontals being parallel. They want to get rid of that parallel. So what do? They get rid of the horizontal line. They diminish it to a point. Much like this guy saying. Now, what does he say about it?
That point.
Well, people tried that, and they realized that then lines had to be finite in length. And they're like, well, that can't be.
So this option was ruled out.
So it was ruled out. They just went, you can't just get rid of lines to get rid of parallel lines, because that'd be ridiculous, wouldn't it?
Yes, so they realized, this Arabic, let's say, mathematicians, that if you are trying to get rid of parallel lines, you will get rid of any lines. Straight lines.
Correct.
Absolutely.
And this is impossible to do because you are just breaking, tearing apart.
Well, your first
whole
postulate
geometry.
is about straight line. You can draw a straight line from one point to another. So
yes,
you can't get rid of the straight line, and which is what you need to do to stop the parallels occurring.
Yep.
Now, that's ridiculous. Obviously, people realised that back then, the mathematicians, the geniuses, even the ones that couldn't prove that triangles have 180 degrees, even them, they realised that that was a load of bullshit. There's a group of people that still haven't realised that that's a load of bullshit. But, I mean, slight trickery going on in the video, and we'll get there in a bit, hopefully.
Contradicted the second postulate, which states that lines can be extended indefinitely.
There you go.
The other alternative is that you can draw more than one parallel line through a point not on the first line.
More than one. Does anybody want to attempt to do that? What do you reckon? That line is drawn there. I'll do it so everyone can see. This is the one, and now we're looking at the one on the right hand side here. Do they look parallel? Do all of those lines look parallel to the other line? Do you think they could be considered as being parallel? Would you like to attempt to call those lines parallel? If you were a mathematician and you're dealing with these parallels, right? Forget about the fact that it's defined as being on a plane, and if extended, they would never meet, right? Does it look like they're parallel? Is that what you call
Well,
No, they are
parallel?
not.
no, they're
They
not.
don't even look.
But there is, funny enough, there would be a way to determine whether any of those lines are parallel, and that would be to have a third line go between the two and determine if the angles on either side equal two right angles. Then, if they do, voila, they would be those two lines would be parallel then. So there is a way to do that, but we'll see in a while they don't like that. That's no bueno for them. Because then triangles would have 180 degrees always. It's consequences.
Yeah. Crazy. So he's already on to his mathematicians are trying to imagine stuff and they can't really imagine one. So let's imagine the other one. This gets interesting now. You thought he was bullshitting before.
So that's what they would do. They would assume that postulate 5 fails. And they're like, this has got to be wrong. Where's the They couldn't find the contradiction.
They couldn't find the contradiction within those lines there, right? They just assumed there were more than one parallel line through that point, and they couldn't find the contradiction. And Kevin's just pointed out that there's a way of being able to prove what they were talking about. But yet they couldn't see the contradiction. Anybody else know a group of people that can't see contradictions that seem glaringly obvious to most everybody else?
Yep.
And these guys are going to pretend that you don't understand mathematics, and they do. This is a Veritasium video page about Euclid and how they got to where they are today. I don't want to be showing the video. I'll show these clips. I like this one. Look at this grinning, smirking guy saying that they couldn't find a contradiction within the more than one parallel line that would seem impossible to anybody that goes along with the definition of parallel from Euclid, because they're not meant to be getting rid of the definitions of things in their
So proof by contradiction also failed.
So proof by contradiction failed. The simultaneous below wouldn't be a proof of contradiction, according to these guys. They can't see it. They can't see contradictions. They've given up.
Total, mathematicians spent more than 2,000 years trying to prove the fifth postulate, but
2,000 years trying to prove the fifth postulate. Anyone believe that?
Seemed to not a chance.
Believe that?
It seemed to work for just about everybody else because it was foundational mathematics for all of that time. If there was a problem, what in mathematics could not be done?
Yeah, nobody falsified it.
Nope.
Right?
Nobody falsified it.
They're just saying that you couldn't prove it. Well, I do think it's a self-evident truth, but I think it's provable easily.
I think so as well. But still, what's the problem being solved?
Yeah.
What's the problem in mathematics that is in dire need of being solved that wasn't that already wasn't handled for 2,000 years and even to today? Like, what's the problem with Euclidean geometry?
It's a perfect axiomatic system. It's just this one thing that they seem to have a problem with. Like, they're bigoted towards this one thing.
Yep.
Within probably the most perfect book we ever wrote within axiomatic system, within mathematics. Oh, thank you, gods. Thank you from everybody who gets a membership.
And by the way, I don't get it, because I can, from top of my head now, I can disprove that there are more parallel lines than one meeting in one point, because if different lines are meeting at one point, so this point is vertex of two lines. And if there is a vertex, there is an angle. So, and it means that you cannot have equal angles, because if you have parallel line and this point, and you will intersect at that point with different line, and you have obviously a vertex between this parallel line and not parallel line, in fact, so you can prove that this additional line is not parallel because there is an angle. So on both sides of this perpendicular, let's say, line, you have unequal angles. So it cannot be parallel. So I don't know why it is, they cannot see contradiction, and it is very easy to disprove. I don't know. I'm not a mathematical genius at all, but I can disprove easily that it is impossible to have more than one line being parallel to given line.
Yeah, they're trying to tell people, they're trying to make it out as though it's impossible to prove this stuff, but it's not. It's self-evident. There could be nothing easier to prove than the basics. The definitions come first, and there is a definition of parallels that they've just not told you about. So there's a definition of parallel lines that comes before this, and now this is an axiom. You can't have this axiom being disproved, or the axiom going against an already set definition. So this is a big trick to me, and I don't think mathematicians would say this. I think this is just for YouTubers and wiki pages and things that have been done in order to end up at this position.
Everyone who tried failed. Then, around 1820, Janos Bolyai, a 17-year-old student, started spending his days and nights working on the mystery. His father became worried, and he wrote to his son, "You must not attempt this approach to parallels. I know this way to the very end. I have traversed this bottomless night, which extinguished all light and joy in my life. I entreat you, leave the science of parallels alone. Learn from my example."
Get that. Right, so this is a letter from Bolyai to his son. And I think we've been over this before, so it may not be new to most people in here if you were there. But he's telling him to leave it alone. And he calls it the science of parallels. Because science at that time would be knowledge. And the knowledge of parallels being straight lines on a plane, if extended, never meet. Pretty obvious. And whether there be a science or a knowledge of what parallels are, I mean, how much knowledge do you need to have? How much are you going to hand over to a mathematician, bunny ears, to do the science of the parallels. It's just parallel lines. It's pretty simple. They're fluffing up mathematics here to a level. Well, it's ridiculous, isn't it? There's just no reason for them to do this. It's like them inflating the ego of certain people for a narrative, for something. But this is a warning. Now, this is the warning that we give to people whenever you're dealing with this. You know, if you've got a model, like this guy says, leave it alone. Walk away from it. You don't want to have anything to do with it. You'll end up going mad, which he did. They don't have a happy life once you allow this infection to come in, and he's trying to implore his son to not do it.
Of parallels alone. Learn from my example.
Because he tried it.
But the young Bolyai didn't listen to his father. He could not leave the science of parallels alone. After years of work, he realized...
Much like George, and I think Blue Marble Science, and maybe Larry, and Jesse Kozlowski, and, you know, all of these people that have to come to this sort of understanding whenever you go into, well, you could say surveying, because the practical application of geometry in reality is surveying, and they have a method called differential leveling. That tells you the difference between the levels from position A to position B, and those are always parallels. The horizontals are always parallel. All horizontals are parallel to the plane of the horizon. So in reality, what you're dealing with is parallels, but these are mathematicians that are trying to imagine something other than that.
That maybe the fifth postulate can't be proven from the other four. It could be completely independent. See, according to Euclid, you could have only one parallel line through a point, but Bolyai imagined a...
Again, he's done it again. According to Euclid, no. Like, according to Euclid...
Not according to Euclid.
If two straight lines cross a line, then you can tell which side the triangle will be formed upon. Not this. This is somebody else's interpretation of the enthymeme wrote in another axiom. It would be like if people kept saying, right, that when we do the, if all horizontals are parallel to the plane of the horizon, then all horizontals are parallel to each other. It would be the same as somebody saying that the horizon's horizontal, because that's an enthymeme within that logical statement, but it's not what's said. And it's not the argument that's been made, as Euclid didn't make that argument about those parallels and these point.
World where there could be more than one parallel line through that point. But how? Well, who said you needed to have a flat surface?
Euclid. Or did Euclid just say a plane? He didn't mention flat, did he?
Nope, just plane.
Yes, but flat surface means plane.
Yeah, well, Euclid did say plane, right? That's within the geometry. It's within definitions. I think it's 5. Is it 6?
That's but he's using this epipedon, epiphaneia. So you can't say, because epiphaneia is surface. And so epipedon would be or plane surface, or you can say flat surface, but it means the same. But
But he's saying, who said it has to be a flat surface? Euclid did.
Yes, so no, not Euclid, but but in fact,
Length times breadth.
Yes, it means the same. So it means that you have to have plane for that.
So Euclid did say a plane.
Yeah.
And this states on the screen, who said you needed to have a flat surface? Well, Euclid said a plane. Because he's talking about plane angles and plane stuff. So Euclid used a plane. So if you're trying to disprove Euclid, then why are you stating that who says you need to have a flat surface when Euclid did say that you had a plane? Because it's not disproving a plane, is it? That's what gets me.
Oh.
On a surface that is curved like this, you can draw more than one line that is parallel to the original line.
There we go. I'll get you a picture of this. He says you can draw more than one line that is parallel to the original line. And we'll just give you a look at it. You can watch the video. Hopefully you do actually go over the video. We'll be going over the video in the Discord, so you can do that. But I mean, look at the three lines that are parallel to the original line. I mean, are they parallel to the original line? Could you say that they are parallel to the original line? Or are you just trusting some guy who's pretending to be a mathematician who's saying that you can have three lines? Are you highly suggestible? How many people actually can take that on? What would you say? What would you say about those three lines? Are they all parallel to that first one?
Nope. Here's the definition of parallel from my version of Euclid. Let me just read this. Parallel straight lines are straight lines which, being in the same plane and being produced indefinitely in both directions, do not meet one another in either direction.
Yes, it means that he puts curved lines, and but he's talking about lines. So he's not specifying that Euclid said about straight lines, not lines. And now he is equivocating them. This one straight line with not straight lines. This is the trick, that he is omitting word straight here. Because the straight line is parallel, but this curved lines are not in definition.
But even if you want to have separate definitions of straight or whatever, right? You're imagining something in a really strange geometry. Is there any way you can have those three lines as being parallel to that other line?
No, because you can put this bottom line higher than the first line, and they will intersect in 2 points.
Yeah, but is he allowing for the fact that you could just draw circles? Right? And they would be not touching, wouldn't they? Like, if that's what you've diminished your definition of parallel to, just never touching, then you could do that. But have they attempted to do that within this definitions of this stuff? Have they ever attempted to define what parallel is? The answer is no. They're leaving it up to people to make that definition themselves as to how. It is just saying that these three lines can be parallel to that other one. There. How can you do that? Well, you do it. Because they're not telling you how to do it. They're just doing it. And
my point is that they cannot be parallel or not parallel, because curved line, this parallelism does not apply to curved lines.
yeah, but if you can imagine the lines as being straight, then you can imagine all of those lines as being straight. And if you can imagine the lines as being straight or calling them straight, then can you also call them parallel? That's the mathematical realm that we're dealing with at the minute. At least
Yes,
the minds of somebody, you know, like, can you imagine that line, or all of those three lines are parallel to that other one? Because that's the geometry that they want you to accept. So you have to imagine that they are parallel.
Yes, so we have paradox here, because in order to imagine, because as I said at the beginning of the stream, you cannot imagine that these lines are straight, because all of them supposedly are straight lines. And you cannot imagine that, because they are different. We can see that on the picture, that these lines are different. There is one line which is straight and others are not straight. So you cannot imagine them being the same straight lines. It is impossible.
Right, I've got
This is paradox.
we've got some body in the chat. It's been a while since Darren's been around, but you know the people that we're dealing with, right? Exploded minds and all that. Well, Darren says the error in your analysis is to use Euclidean specific definitions and words into the generalized case. The words are the same, different definitions. What does that mean? Who knows? This is from the mind of the exploded mind of a dogmatician. He also then goes to say, do not apply Euclidean definitions to other geometries. That is why they're non-Euclidean. So there should be some non-Euclidean definitions that Darren can give us. There won't be.
He cannot.
No, there won't be,
There
because
won't,
he's
yeah.
just making it up. Darren's not really
And
got
that-
a clue about what he's talking about. He's even got less a clue than Veritasium. But yeah, welcome for being here, Darren.
And by the way, these Arabic mathematicians, they were using Euclidean axioms
Yeah.
in order to disprove something or to do anything.
And since
With-
the axioms come after the definitions, then you have to take the definitions as well. Like, I don't know what Darren's talking about, but you can't get rid of the definitions of a straight line, because that's the definition of a straight line within basic mathematics. Don't forget, Darren, that all of modern mathematics is based upon this foundation of Euclidean geometry and mathematics. All
By the
of
way,
it.
straight line is not invented by Euclid. Before Euclid, people like Plato and others, they knew what straight line is. So if he's saying that this is not Euclidean, so I would say that definition of straight line is originally not Euclidean, because he is saying about general things. Yes, so I would say that Euclid just used general statement about straight line. This is not his own invention.
Yeah, he's not talking about just I think he's talking about parallel lines. I think he's talking about the definition for parallel lines. He's saying you can't use the Euclidean definition of parallel lines when you're talking about the parallel postulate, because that only applies to Euclid. There has to be a different definition that he obviously won't apply or bring or state what he means by it at all. Probably gone for a good. See you later, Darren. Nice try. But I suppose somebody's got to do it, haven't they? Somebody's got to defend.
But you still need other requirement, and this other requirement would be not plane. And it was said in this film. So you cannot have this differing straight lines. In fact, one straight line and curved lines in plane.
Yeah, Darren says, it abstract mathematics. Non-Euclidean geometry is abstract. Euclidean definitions describe quite specific norms in the way people view the world. Yeah, that's what we're saying, Darren. Euclidean is for reality.
Yeah, but still, whole mathematics is abstractive thinking. And logic is abstractive thinking. So he cannot say that you cannot use Euclid because it has link to reality. But it is still abstractive thinking. So my conclusion is that we have only one abstractive thinking that can be applied to reality. And other abstractive thinkings cannot be applied to reality, and therefore they are wrong.
Yeah,
this is my conclusion.
One of them can be applied to reality and proven within reality. The other ones cannot. Right? So that's what makes them provable or not provable. Not the redefining of definitions. That doesn't help you. You still have to attempt a proof. And since you can't even come up with the redefinitions of things or the new axioms that you want to apply to your geometry, I'd say you don't really stand any chance of giving a proof. Brenda's saying there's no triangles in reality. That's interesting, Brenda. Very interesting.
But wait a second, those lines don't look straight. Well, what makes straight lines special is that they're the shortest paths between 2 points. On this
shortest path, you remember hearing that from someone? They did like not the shortest distance, shortest path. Who was that? FE Math it was, wasn't it? It's almost as though these guys were practicing whenever they were doing that, coming round here talking shit, just so they can get somebody to make a video about stuff. It's really weird. It's like they come round practicing.
Surface, those shortest paths just look bent because the surface is curved. Here's a more familiar example. Airplanes always try to fly the...
Right? Remember what we said at the beginning? That no parallel lines has been took out. Well, no parallel lines occur on spherical geometry. Yet this introduction is going to use spherical geometry, which they've just disproved and said that they can't have it. And here they are again. Sneak a little trick.
The shortest path between two cities. They're basically flying in a straight line, but that line doesn't look straight on a map because the surface is curved. These shortest...
Look, and do you want to see that? Here we go. This is the shortest path on a curved surface, much the same as the parallels. It probably didn't look parallel earlier, and this probably doesn't look like the shortest path between those 2 points either. But you have to take this on as though it is. There's just no other reasoning behind it. These grids may look like the sides are parallel here. They may look parallel, and that's because they are. This grid and all of this, they're parallel. And the shortest distance between those 2 points would probably be a straight line. But they want you to imagine the red line has got something to do with the shortest distance. This is Bob's territory. Bob did an argument about this. We went over it a couple of weeks ago. So we'll leave Bob to take over for that one. He probably helped out. He must have done, really, right? Bob must have done that driving for him.
Paths on curved surfaces are called geodesics.
Interesting fact, a geodesic in Euclidean space is a straight line. Brenda says that's a map projection of the globe. Non-developable surfaces, Brenda. That looks like it's on a plane. It can't be expressed like that. Yeah.
So all these lines are straight, they just don't look it because the world Bolyai had imagined turned out to be curved.
So, right, so this is where people like Brenda and all of that have to... I don't know whether you're model afflicted and whether you have the ability to do this. I can do this. Those lines are straight. They just look curved. Because what you're seeing is a curved surface. Right? If you can look past the curved surface and imagine those lines are straight, then you'll be closer in the mindset of Bolyai, right? Because he's not imagining it as curved. He's imagining it as though it's just a plain surface and that they are straight. He just can't see them as being straight because he's imagining curved. Because what they're talking about is Bolyai, right? Now talking about this, imagining it as it being curved. But in a minute, they're going to tell you that he used Euclidean geometry and straight lines. So he's actually using straight lines, but imagining the straight lines are actually curved. So he's not seeing it on this surface. He's seeing it on the plane, like Euclid would. His mind is broken. Madman, really. These guys are portraying this for you so you can see it. He didn't have this ability. He was literally using a flat plane and imagining it differently. This is a bit of a disservice, really, to what he's doing.
We now know this as hyperbolic geometry. You know, when I used to think of the hyperbolic plane, I would just imagine it as one giant saddle. But that's not really what it is. The hyperbolic plane is much more like this piece of crocheting.
Right, the hyperbolic plane, not spherical geometry. This is the hyperbolic plane. And here's a picture for you guys. And there's the hyperbolic plane. That's what it looks like. So when he's drawing triangles on a piece of paper, you have to imagine that this is what he's thinking of. Of course, he wasn't actually thinking of a crocheted thing like this. But that's what they want you to imagine that Bulli was actually doing. They're having to try and make it like it's less ridiculous than it is, but in his efforts, he's now got a piece of crochet, and he's trying to convince you that there's some sort of mathematics.
So it starts out pretty flat and even in the middle, but as you move outwards, more and more fabric is created, and that would push parallel lines apart. And the further and further out you go, the amount of fabric grows exponentially, and that ends up causing this crumpling effect. So if you really want to think about the hyperbolic plane, I think you've got to think about saddles on saddles on saddles, like it's an infinite crumpling mess.
So remember that. You've got to think of it like it's an infinite crumpling mess whilst you're drawing triangles on pieces of paper. Just, you know, put your mind there. It'll be dead easy. Well, I mean, not unless you've experienced it. Brenda, I would imagine Brenda'd be really good at this sort of stuff. I bet Brenda's good at crocheting as well.
But that little piece of crochet isn't the full hyperbolic plane. To show that, we need to make a map, one that fits the entire plane into a disk.
So this is a map, right? Now, you know, when like people like Brenda and all of that are asking what they call flirfs to give them a map. Well, this is the hyperbolic map coming up. I'll get
to show how this works, we're going to fill the entire plane with these triangles. Starting in the middle, just as with the crochet, things look pretty normal. But as
so, I go back a bit.
A disk. To show how this works, we're going to fill the entire plane with these triangles. Starting in the middle, just as with the...
Right, here we go. He's making triangles, right? So... you might be able to see there's a slight difference between the triangle in the top left-hand corner that he's starting with and the triangles that fit on the plane. There you go. Imagine that. He's laying these out.
Crochet, things look pretty normal. But as you go farther out from the center, you get all this extra space, so you can fit more and more triangles. So they appear smaller, but they are actually the same size. Now, since the hyperbolic plane is infinite, you can keep adding triangles forever, and they all need to fit on the disk. So as you get closer to the edge, the triangles will appear smaller and smaller and smaller, infinitely smaller, never ending, and you can never quite reach the edge.
It's even the way he's saying it. It's like it's magical. Remember, have a look at this. All of these triangles, so-called triangles, are the same size. I remember about the tweak at the beginning that we did and how he managed to make up new universes from his broken mind. Well, all of those triangles, yes, they've not got straight lines, but, you know, one of the allowances you have to make for you to put your mind in the same place as a madman is to imagine that they are the same size and they are straight. This has got nothing to do with level and horizontal, guys, in the chat. Please don't get distracted. This is mathematics. It's got nothing to do with level or horizontal. We're dealing with straight lines. That's it. In a new geometry. It's not the geometry that Brenda wants to talk about, right? So if people are being allowed to get distracted from what we're actually going over here, then, you know, it's because they're not talking about the geometry that Brenda wants to talk about. It's because Brenda wants to get all into a level conversation. We're not talking about level, Brenda. Will you stop talking about level and horizontal? It's all you keep going on about. And what's Darren talking about? The shape of the earth. It's all you ever go on about, Darren. What's this got to do with the shape of the earth? This is how you imagine hyperbolic geometry and how those triangles are actually the same size. You're not listening. Oh, well. Brenda's distracting people in the chat, okay?
This is known as the Poincaré disk model. Here, straight lines are arcs of circles that intersect the disk at 90 degrees. And just like on our original shape, a straight line down the middle appears straight, while straight lines reach the edge. This is known as the Poincaré disk model. Here, straight lines are arcs of circles that intersect the disk at 90 degrees.
Right, and now we had a meeting, a guy come on here. He was called Flat Earth Math, right? And he was the one that was saying that straight lines, or the diameter of a circle, intersects the circumference at 90 degrees, much like what this says here. I mean, it seems impossible, but we're dealing in hyperbolic geometry. You have to imagine that they're all straight lines. Therefore, the right angle, which are all equal, would obviously be between two straight lines. Now, if you can't imagine that they are straight lines, then don't be thinking that it looks ridiculous, because you're looking at a circle and a curved line, but they're not. They're in hyperbolic geometry. They're straight lines. You, because you're looking at it within Euclidean space, you're not able to comprehend that the straight lines that you imagine aren't the straight lines within this geometry, because you can't have a right angle between lines that aren't straight. They're all equal, although these lines here, where the right angles meet here and here, obviously are not equal. Therefore, you are not imagining them as straight lines. If you're seeing them as not equal, then you're not looking at it correctly. You should adjust your thinking into placing these as straight lines. That's right, isn't it, Brenda, Darren? In the abstract, you've got to take yourself out of your Euclidean reasoning and put yourself within a hyperbolic in order for you to get a grip of what's going on here. It's hard work, but this is what mathematicians have to do, not modern day mathematicians. You're best off leaving it, because unless your mind has been pre-prepared for it, you'll probably end up going mad.
And just like on our original shape, a straight line down the middle appears straight, while straight lines next to it appear to curve away.
So yeah, these are all straight. It's a shame I can't really put this in. So these are all straight. That's right, isn't it, Darren? Abstractly straight.
What's remarkable is that Bolyai didn't have a model of hyperbolic geometry yet. He was just drawing Euclidean triangles with the assumption that Euclid's fifth postulate didn't hold.
So, did you hear that? Do you want me to read it again or let him go over it again? So, that hyperbolic geometry and this bit here with straight lines that aren't straight wasn't what Bolyai had. Bolyai was just drawing triangles, Euclidean triangles, and assuming that they weren't applying to the axioms of Euclidean geometry, right? He was just imagining differently, although he was just using Euclidean. And I'll play it again. So, I mean, Veritasium can say it for you again.
And just like on our original shape, a straight line down the middle appears straight, while straight lines next to it appear to curve away. What's remarkable is that Bolyai didn't have a model of hyperbolic geometry yet. He was just drawing Euclidean triangles with the assumption that Euclid's fifth postulate didn't hold. And while Bolyai found that the behavior in hyperbolic geometry is very different than Euclid's, mathematically it seemed just as consistent.
Right, so he didn't have a model. He was just using Euclidean triangles and drawing Euclidean triangles and just assuming that the triangles didn't have 180 degrees. But it seemed consistent because the triangles obviously did have 180 degrees. He was just imagining them differently. And that's where you have to put your mind, especially if you've fucking gone mad.
Yes, but this guy said that Bolyai thought that fifth postulate does not hold.
Yeah.
It means that this postulate is wrong. So if it is wrong, it means that he cannot use. So in fact, he cannot use triangles.
But he was.
Right? Yeah, but
he didn't,
so he was
didn't even have the
violating
hyperbolic model that these guys have just spent 5 minutes explaining to you that Bolyai didn't actually have. If that's not a trick, I don't know what is.
He is violating his own thinking.
Yeah, because he was mad. His dad told him, don't try and do this. And then he wrote his dad a note saying, I've discovered new universes from nothing. That's the sign that he's mad. He's already mad. And now he's drawing triangles, actual Euclidean triangles, and just imagining that they have more than 180 degrees without a model to work upon.
In 1823, the 20-year-old Janos wrote to his dad, "I have discovered such wonderful things that I was amazed. Out of nothing, I have created a strange new universe."
There you go. Come on. There we go. Out of nothing, I have created a strange new universe. What does that sound like? Who creates universes out of nothing?
God. That's a God complex. That's a guy with a God complex.
It's a guy sat in his bed writing a letter to his dad saying, I'm God.
Yep. Yep.
He's a mathematician, though, right? He's not lost his mind and gone mad, thinking he's God. His dad's told him not to do this, otherwise you'll go mad, son. And now his son's writing to him,
saying, I'm God.
I'm God. Yeah, you want to see what I've
Yep.
done.
Yep. Is it any wonder? You think he's insane?
Mm-hmm.
Yeah,
It's just
I
a
do
brilliant mathematician, right? That's what they're billing him as. I mean, I'd say no, he's a fucking madman, thinks he's God.
He was an insane young man, sounds like to me.
Yeah, his dad said, look, learn from my mistakes. One of the letters his dad wrote him was that he'd gone to sea, and every time he'd returned with his masts broken and his sails shredded, every time he attempted to do this. And now his son's sending him messages that he's God. Genius mathematician or madman? It's up to you. You decide.
Or God.
Oh God, yeah, he could actually.
Yeah, I mean that's a third choice. Yeah. He was God. Yeah. Watch how they play him up.
Bolyai had been doing more than just tackling ancient math mysteries. In his 20s, he joined the army.
Right, yeah. So Bolyai, as if to say that he's just said he's God. Right now, we're going to go through a little bit of misdirection, right? Sleight of hand. This is math trickery, math magicians, mathemagicians sort of work here now.
Where he continued developing two of his other passions, playing the violin and dueling. He had mastered both, but with a sword in particular, he was unmatched. Perhaps because of his many talents, Bolyai grew arrogant and found it difficult to accept authority from his superiors. That made him hard to get along with. This reached
I'd imagine
when, during one of his
pause it here for a second. Yeah. I'm saying this in all seriousness. I would imagine God would be the same.
Yeah. Hard to deal with.
This is
sort of arrogant.
Yep. This is Veritasium, I think, claiming that Bolyai was God. Or a god, at least.
Well, yeah, they've stepped out of Euclid, right? This is one of their ways of expanding mathematics beyond Euclid. And, I mean, that's dangerous stuff to be putting your mind in that position.
Deployments, 13 cavalry officers from his garrison challenged him to a duel. Bolyai accepted their challenge on the condition that after every 2 duels, he could play for a little while on his violin.
Okay, might have happened, might have been real, but the inclusion of the violin playing dueler into this story right after you've just been told that the guy thinks he's God.
He's God. Yeah.
Like he's a massive distraction tactic. I don't know what this is adding in for. They're trying to get you
verifying,
on side.
Or verifying he's God.
Well, he could
like
be,
that's
yeah.
because that's how I saw it.
God
That's how I saw it.
13 people. He did have 13
I don't know,
disciples or something, didn't he?
Yeah, if you count
so he's anti-God. He's fought 13 disciples rather than he's dueling them.
Yeah.
Maybe symbology, who knows? But
who
I mean,
knows?
he's definitely added it into the story. Sounds a little bit weird, and I don't know why he's added it. It doesn't add anything to the story at all.
Bolyai fought each of them in succession, winning all 13 duels and leaving behind all his adversaries on the square. While Bolyai loved dueling, his first love was still mathematics. In 1832, 9 years after he discovered his strange new universe, he published his findings as a 24-page...
So 9 years after he found his strange new universe. He's going to write a 24-page paper, I think. 24 pages to put to this.
He said found. He said found his strange new universe. He created it according to his.
Yeah.
So
found, created, bit
founded,
downplay.
maybe. Yeah.
Page appendix to his father's textbook.
Right, and I'll get you this thingy, because so this guy has done some drawings, right, to add to the textbook, 24 pages, and this is what it looks like. Put it in the chat there for you. You may say it looks like Euclidean, and the reason for that is it is. That stuff that they were telling you about earlier, Bully just didn't do it. They made that up for you. They made you think that he made it up, but he didn't. They've made it up afterwards to make him look a bit better. Yeah.
Mm-hmm.
Just a big trick. Didn't happen the way they say it, and they're portraying it, yet they're telling you that it didn't happen the way it did. You've got to be able to see through this.
Extremely proud and excited about his son's work, Farkas Bolyai sent it to perhaps the greatest mathematician of all time, Carl Friedrich Gauss.
Right, so he sends his son's work, 24 pages, to Gauss. And what's Gauss going to say?
After careful examination, Gauss replied a few months later, "To praise it would amount to praising myself, for the entire content of the work coincides almost exactly with my own meditations, which have occupied my mind for the past 30 or 35 years."
So, Gauss does a QE and goes, I did that already. I've already done it.
Yep.
Like, that was my work. That is exactly the same as what I did 30 years ago.
Imagine that.
Yeah.
And then nothing, by the way, nothing further, no elaboration on his father's warning to him and suddenly being excited for this whole thing. I'm not sure I buy that whole story. I think his father likely thought his son was out of his freaking gourd.
Yeah.
And potentially sent this to Gauss to have a go. And maybe Gauss thought, hey, I could really use this thing.
Yeah.
This would be great.
Yes, and by the way, Gauss said that he is God also, and even he was God earlier than Bolyai.
Yeah. Yeah,
So
I've
this is
already
not
done
the-
those universes.
Yeah,
fucking-
I was God the first, previous than you.
Is it any surprise we're dealing with these types of people that think they're God? Can anyone think of any others that maybe we've dealt with in this arena that think that they're God? You don't have to answer that question. I was just, it's rhetorical.
Yes, I can, Kevin.
Thank you, Bev.
Years earlier, Gauss had wandered a similar path. In 1824, he wrote a private letter to one of his friends in which he describes discovering a curious geometry.
So he wrote a letter to his mates so he's got some stuff. It's like he kept it private, right? So just a private letter that Gauss wrote.
With paradoxical and, to the uninitiated, absurd
I'll get that for you. So this is what Gauss said. Oh, come on. This is about the geometry that he did. He called it paradoxical and, to the uninitiated, absurd. So, like I said a bit earlier, unless you've been initiated into understanding that what you see as not straight are actually straight, you may see it as absurd, because, I mean, you can't have a right angle to a curve, but you're not seeing it right. You're not initiated in knowing that what you're seeing as straight should not be straight, but you've got to imagine it as straight. Especially when you've got Bully Eye, right? He's drawing straight lines. So you've got to imagine that the triangles that he's drawing have more than 180 degrees. But the straight lines that you see as straight aren't meant to look straight, but they are actually straight. It takes a lot for you to be able to get into this, to be able to see the geometry hidden behind the absurdities that you initially see when you look at it.
I would agree. It does take a lot for you to be initiated into this thinking.
It may seem like nonsense, like forever, right? Some people may look at this and just see nonsense. And that's not unsurprising, right? There will be a lot of people that do that because it is nonsense. You've just got to see through the nonsense to try and make sense of it. That's how you progress in modern mathematics. It's not for everyone. And, you know, people say that we don't really understand this. Well, you can't really understand it. You just have to look beyond it and see through the absurdities. And I understand that a lot of people, including the ballers like Brenda and that, I would imagine that they also can see through the absurdities. That's why sometimes it looks ridiculous and they also look ridiculous. But you've got to see through the absurdities of what they say. People can't
theorems. For example, Gauss writes, the three angles of a triangle become as small as one wishes. If
I'm going to show you this, right? Yeah. Check this out. See through the absurdities, right? That's what you've got to do. The three angles of a triangle become as small as one wishes if only the sides are taken large enough. So you lengthen the sides to make the internal angles less. Sounds contradictory. In fact, it is contradictory. You just have to accept the contradictions and go with it because this is seemingly absurd.
If only the sides are taken large enough, yet the area of the triangle can never exceed a definite limit.
So the area can't get any bigger. That's fascinating, isn't it? Like other triangles, you can make them as big as you want. You just lengthen the side and the triangle increases in area. But in this one, you lengthen the sides, you can make the angles smaller, but the area can never go beyond a finite limit, a definite limit. It sounds backwards, and that's because it is. You've just got to accept it. You've got to go with it. You've got to accept the contradictions that it sounds absurd and break past it.
In other words, you can have a triangle that's infinitely long, but the area is finite. You can see why by using the Poincaré disk model. A small triangle looks pretty ordinary, but as you make it bigger, the angles start to become smaller and smaller. Eventually, all those angles go to zero.
Here we go. Angles go to zero. A zero angle triangle on the Poincaré disk model. Coming in the chat. There you go. Boom. 0 angles. But you'd never say that you saw a triangle with no angles. And try 0 angle. Try non-angle. Could you even have try non-angle? I guess. Anything's possible. There it is. You're looking at it.
There is another contradiction here, because he said that you can have, in fact, infinitely long, let's say, arms, and you have still finite area. You cannot have that. This is impossibility. And Aristotle proved that in many ways. Even in his work in Cello, you cannot have finite area with infinite, let's say, arm or side of this triangle. It is impossible.
Well, didn't they do that with the, do they call it a pseudosphere? The inside-out sphere has, what was it called? J-Ro over here. Is it called Gabriel's trumpet or something? It's a mathematical, I'd call it a paradox, where it has finite volume, infinite area, I think.
I would say that this is called paradox because paradox means impossibility.
Yeah.
So it is impossible.
But, you know, it's incorporated within this geometric structure of a 0 angle triangle. Yeah.
Because all these lines intersect the disk at 90 degrees.
Let's see, look, again, I have to, it's going to take me ages going through this, isn't it? All these lines intersect. There you go. All those lines intersect the disk at 90 degrees. Similar thing that we said to flat earth math. Flat earth mathematics. He said that except he was talking about the diameter intersecting the circumference. Whereas we're dealing in this sort of hyperbolic geometry. I don't know whether flat earth math has got confused, whether he's grabbed hold of the concepts of this hyperbolic geometry, which is obviously, you know, not Euclidean. And flat earth math has placed that within the Euclidean realm to say that the diameter has a 90-degree angle with the circumference, which he has. He's definitely said that. I'd say that these two geometries are different because hyperbolic geometry, you're seeing straight lines, actual straight lines. You think you're looking at a circle, but you're not. Within Euclidean geometry, you are looking at a circle. That's the difference between this geometry and Euclidean geometry. Euclidean geometry is exactly as it looks in reality. A square has parallel lines. This is a different type of geometry altogether. Please don't imagine that this relates in any way to the circle and curved lines and arcs of Euclidean geometry. It's not the same in any way. These, what you're looking at on the screen right there, are straight lines. They may look curved, they're not.
But there is a contradiction here I spotted, because he said that you can have these angles being 0 angles, but this is inconsistent with what Flat Earth Math admitted, because I have asked him about this angle, and he admitted that it is not at this point because it is asymptote to zero, but it is not at 0 point. It cannot be. So if
you've got to watch what you're doing, because this is hyperbolic. Don't forget, Flat Earth Math, he's imagining spherical geometry. He's not even contemplating hyperbolic. He's got it completely mixed up, right? This isn't the non-Euclidean geometry that Flat Earth mathematics imagines. He's trying to imagine spherical geometry, and that's different, completely different than this hyperbolic. In this one, these lines that you're seeing, they are straight. In the spherical geometry that Flat Earth Math and Blue Marble and Brenda and Darren and all them want to imagine for their dogmatic globe model, there are no straight lines, right? Or not, they're not straight lines like you're imagining these straight lines are, because they're not allowed to be finite, are they, in the other one?
Yeah, but if they are not finite, it means they cannot meet, in fact.
Yeah, they've got spherical geometry has its own set of problems, and don't confuse them with imagining that all of the lines are straight within hyperbolic geometry.
No, I am not. I'm not trying to compare this to Euclidean geometry. But if they are saying that they are just approximation, so asymptotes, so in fact, it is not a triangle even. Because in this hyperbolic plane, or whatever they call it, this plane is infinite. In fact, they draw a circle here, but in fact, it is infinite.
Yeah, you're looking at the boundary of infinity at the outside.
Yeah.
Yeah.
So this line is still a plane, curved plane, or whatever they call it.
It's a hyperbolic plane, yeah. Yeah, you may be looking at a circle, but like he said, you've got to imagine it as that crocheted fluffy, right? In all ways. That's what you've got to put your mind. You're looking at a circle with some lines on it, but you've got to imagine that those lines are extending out to infinity. It's hard work. It's not for everybody to imagine, that crocheted thing when you're looking at this. It's hard work.
Yeah,
to the uninitiated, it may look like it's absurd.
Yes, it is, and that's why I would say that this is paradox about this area, because if they are extended indefinitely, it means that their area is also infinite. You cannot say that this is finite area. So this is another trick. I would say that just a fraud.
What's Darren talking about? Darren, what are you on about in Blackpool and stuff? Who are you talking to? You're just randomly talking to no one. I mean, check this out. For somebody talking shit. Darren talking about Southport and Blackpool when we're talking about Poincare discs. Hyperbolic geometry. He must be bored of it. It's got no spherical geometry in it. He says it does. So why does a horizontal straight line established at Southport have an elevation of 120 meters at Blackpool?
It hasn't.
Well, I mean, could it be established at 120 meters at Southport?
It could, but this
And
is
then
not
it would have an
established as-
elevation of 120 meters at Blackpool as well, wouldn't it?
Yeah.
So that's how, Darren. It has an elevation of 120 meters at Blackpool because when it's established, it's been established at 120 meters at Southport, because that's how elevations work. It stays the same. I don't know what you're talking about, Darren. You're mad. It appears like you don't know what you're talking about. I thought you'd come in to do some geometry talk, not about elevations at Blackpool. They're obsessed, man. I bet you've never even been to Blackpool, have you? Or Southport.
Now, these lines are infinitely long, but because of the geometry, the area is finite. In the same private
Impossible.
letter, Gauss wrote all.
Go on.
Just as I said, impossible.
Yeah.
It is just impossible.
He's talking again. Oh, let me go back, see what he says.
These lines are infinitely long, but because of the geometry, the area is finite. In the same private letter, Gauss wrote, "All my efforts to discover a contradiction and inconsistency in this non-Euclidean geometry have been without success."
So he can't find a contradiction either. Gauss has just placed
strange.
himself in the inability to find a contradiction.
I have pointed one just
know.
now, so I don't know.
So, like, what was up with you? Like, are you cleverer than Gauss, or has Gauss been afflicted by some sort of logical break that stops him from being able to see contradictions? Like, what's going on?
I think so, yeah. So he went mad, I think, maybe.
Sounds like it, doesn't it? If you can't see glaringly obvious contradictions, then you might just be mad. And there are lots of people that modern day time can't seem to see the contradictions, and they can't. Not only can they not see the contradictions, they cannot come and ascribe themselves to why there is no contradiction, right? They can't discuss the contradiction that they can't see. They can't defend why there is no contradiction or anything.
I think this is the similar problem in this, let's say, triangle on that surface, like this Georg Cantor had, because he wanted to compare two infinities. When you divide a section into infinity, and when you can have infinite number of sections or units. So that was Cantor problem, and he also went mad, and he ended in clinic. And this is, we have two infinities now, area and sides of this supposedly triangle. So for me, it is similar thing that mathematicians started to deal with infinity. They are trying to encompass and make it finite, infinity finite. Because, you know, if you, because the property of God is that you can know infinitely, yes, you have infinite knowledge, but we are finite entities, people. So how to make it how can people have infinite knowledge when they have finite capabilities? And I would say that that is mathematician approach to that problem. And of course, you will end mad.
Well, I
if you
think
try that.
I think that they don't end up wanting to become God. It's the break within the logic that destroys the mind, that then allows them to become the logic that was holding you back and keeping you confined within reality. That's broken. So you go beyond reality, and then you end up in this strange place where you just imagine that you are God. You can do all sorts of things. You can do anything you want, really. It must be freeing to these people, but to the outside it looks ridiculous and looks like madness.
Yes, I think that people realize that with our human reason, we cannot have infinite knowledge. So what they are doing, these mathematicians, they are going beyond our reason, which is impossible. But they claim that they are going beyond reasoning, and they put themselves in that place, which is nonsense, pure nonsense. And this they call, let's say, nirvana. This is the nirvana state. Pure nonsense, idiocy, madhouse, etc. This is this highest knowledge for them. This, for me, this is just sad, but seemingly this is what they are doing.
It must be bad, but like, I don't know why, but for some reason, I don't have a model, so therefore I can place myself in these ridiculous positions where it does seem absurd, but as long as you take the idea that straight lines aren't straight, then the geometry can work. But you're giving up the actual straight line to be able to place your mind there.
Yes, but this is in what you just said, it is contradiction. Because it means that you cannot have everything in this geometry, because you cannot have straight line. So you have limit. And this is, I would say, upsetting part of this geometry, because if mathematician wants to know everything, it means everything. And in that everything would be straight line also. But he cannot have this straight line in his geometry. So it means that this geometry cannot say everything about everything.
I think that's why the mind breaks, because you have to accept that reality wasn't the thing, right? This other thing is where straight lines actually are, which means you have to give up the reality straight line, because you can't have this other thing being the straight line whilst the reality Euclidean straight line exists there. You've got to take your mind out of that place. And for that reason, it's dangerous for the mind that lasts within reality, because you don't leave reality, just your mind leaves reality. That's dangerous.
And this is, you know, as Aristotle said at the beginning, I think, of metaphysics, that this is in human nature to know, that desire to know. And to know is to prove, as Aristotle stated many times. So they in order to have things that they cannot prove, they have to give up with things that they can prove. And it means that they are just abandoning, they are retreating from science into fantasy. They are giving up proofs to have some fantasy stories. And this is an inevitable process. So you cannot have you cannot have things with proofs in that geometry and without proofs. You have to choose.
Yeah, well, you're giving up proofs to have a new strange universes.
Yeah,
right?
yeah,
You're gaining universes of stuff that you didn't have before. You just have to give up the reality proofs.
Yeah, yeah. That's what I meant.
That's the exchange that you make. And also you will be deemed as being mad. But you can have your new strange universes. Not everybody gets that.
Just like Bolyai, Gauss had found that this geometry seemed thoroughly consistent. He named it non-Euclidean geometry, a name that stuck. It describes geometries where Euclid's first 4 postulates hold, but the 5th doesn't. But Gauss decided not to publish his findings for fear of ridicule.
Gauss didn't find it for fear of ridicule. I wonder why that was. Why?
And by the way, this 5th postulate holds, but description of this postulate given in that clip is wrong. So in fact, he is not talking about real 5th postulate, but he's defying his interpretation or Bolyai interpretation of 5th postulate. So keep that in mind, that he's talking about 5th postulate, but really he's not talking about 5th postulate. That's the trick, because it was about straight lines and third line, etc. And we have 1 point above straight line and some non-parallel lines whatsoever. So it is not 5th postulate, but he is talking about 5th postulate. So he refuted 5th postulate, but refuting not 5th postulate.
Yeah. Yeah, the one that they changed.
Yes, they changed into something else, which is not 5th postulate. But they claim victory. We just defeated 5th postulate. And they didn't.
And inconsistency in this non-Euclidean geometry have been without success. Just like Bolyai, Gauss had found that this geometry seemed thoroughly consistent. He named it non-Euclidean geometry, a name that stuck. It describes geometries where Euclid's first 4 postulates hold, but the 5th doesn't. But Gauss decided not to publish his findings for fear of ridicule. This aversion to a different kind of geometry should at least be a little surprising, because there is one other geometry that we should be very familiar with.
Right? This is where body language experts should come into this. He's talking about this. Like, there's another familiar geometry we should be very familiar with. Slight look away. Because he's having to imagine something that we should be very familiar with it. But it was disproved at the beginning. They crossed it out and went, nah, not that. They've just gone through a whole bit of hyperbolic geometry after saying, no, not this one. But now he's bringing it back. This is very clever, this.
Spherical
Yes,
geometry, since we all live on a
I
sphere.
can name it even
Yeah.
because it is perfect example of Hegelian thesis and antithesis. So he was talking about Euclid, which is very reasonable. Then he was talking about hyperbolic geometry, which is completely nonsensical. And now in the middle, he is putting spherical geometry. So according to Hegelian method, we have thesis and antithesis. So thesis would be Euclid, antithesis would be hyperbolic geometry, and of course the truth is in the middle between nonsense and truth. So it is spherical geometry, and this geometry, spherical geometry, according to this method, Hegelian method, is the true one, because it is in the middle between true and nonsense.
You think?
This is how they did the trick.
No, I don't think so. I think this is just a tis globe bit, right? This is his tis globe, right? Because they played the tricks with Euclidean and the other one, and then this is the tis globe, right? Everybody knows tis globe. We all live on a globe. And
Yes, I agree. Yeah. But he is using Hegelian method. For me, it is just obvious.
Where the place where no parallel lines means you can't have a finite line. And he wants to say that's reality, right?
Yes.
Very clever.
But in Hegelian method, it is not... The truth is between truth and nonsense. So, of course, it has to have many nonsenses inside, but not as many as in hyperbolical geometry. That's the trick. So this is compromise.
I don't think so. Hyperbolic, they say, is a true geometry. Euclidean is obviously a true geometry because it has an axiomatic system. Hyperbolic manages to make itself into a true geometry. I don't know how. But spherical geometry cannot be a true geometry in the same respect as Euclidean and hyperbolic, because its starting base is a Euclidean sphere. So it's in no way is it comparable to either of the other two geometries that they've imagined. Hyperbolic geometry really isn't a geometry, but in this mathematical thing, you can imagine, if you can imagine that the circle isn't a circle and it's a hyperbolic plane, which is like a crumpled up mess, and the outer edge of it is infinity. If you can put yourself through all of that, and straight lines are intersecting perpendicular to the... I mean, it's ridiculous, but it's a geometry all of its own, right? It's a self-contained geometry, whereas spherical geometry just isn't that. At best, it's a reliving of spherical trigonometry, all based around Euclidean stuff, with the imagining that you can have this straight line that isn't really a straight line of what they've prepared your mind within hyperbolic. They needed hyperbolic to be able to put your mind in a certain place, and then you can apply that to spherical. But the problem is, once you've done the hyperbolic, your mind's been broken, and you'll come out of it the other end like flat earth math, thinking that Euclidean is also like this as well, with the 90 degrees to curves. This is the true danger, I think, within it, is conflating these two, hyperbolic and spherical. Which, I mean, I'm not in danger of doing that, but I think there are people that may be listening that are capable of doing that, and they probably already have. Imagining their imaginometry is being imagined as different geometries, applying these broken logic rules to each.
On a sphere, straight lines are parts of great circles. These are the circles with the largest possible circumference. On Earth, the equator and circles of longitude are examples of great circles. And we can use this to see how straight lines behave.
Right, you can use this to see how straight lines behave. Go back to the beginning axiom, one of the axioms of Euclidean geometry, that obviously it still exists within these, and it states two straight lines cannot enclose a space. That's
Yes,
an
and by the
axiom
way,
from reality.
and you can extend straight line indefinitely.
Yeah.
And here you cannot.
Well, they're going to tell you now what happens to straight lines.
These lines seem to go in the same direction, but as you keep extending them, you find that they intersect once and then again on the other side of the Earth. And
right, so two straight lines not enclosing a space becomes, whenever you deal with spherical geometry, two straight lines enclose two spaces.
Yes, and by the way, he is using the same word that he used in hyperbolical geometry. He always says it seems to. Never in Euclidean geometry is said anywhere that it seems to be so. Euclid never said that in his book. It seems to be that. No, he said it is that, or it has to be that,
Yeah,
or it is proven to be that. But he is using word it seems to be. This is not geometrical expression. Geometry is not strictly referring to visual. So it means it is just a visual trick, not real science, for me at least.
yeah. Two straight lines cannot enclose a space becomes two straight lines enclose two spaces. Doesn't have the same axiomatic ring to it, does it?
Yes.
Sort of tells you it's a load of bullshit, right? Except this one, they want you to believe is the measurements taken in reality. Like the hyperbolic, they were honest with that, right? You've got to put your mind in a different place. The boundary is infinity and it looks ridiculous, like a crocheted mess with ever expanding things as you go out to the edge. It may look like they're getting smaller, but they're not. They're staying the same size. Whereas this, they're trying to tell you that this is reality. They're trying to literally break down Euclidean. This one's more, this was the worst, right? This is the true deceit coming out right here. You can understand the hyperbolic, right? Messing about in the mind, putting your brain in a different place and imagining something. This isn't imagining. This is them literally taking Euclidean rules and laws from reality and just changing them and trying to tell you that this is reality as well at the same time. This is where it gets worse. in my opinion.
This will always happen for any two great circles, because they must each have the largest possible circumference. So on a sphere, there are no parallel lines. Gauss.
Now, in reality, all horizontals are parallel. So that tells you that it's not a sphere, or at least that's what you would think quite easily, knowing that there are parallels in reality and that on the surface of a sphere there are no parallels. Sort of makes a mockery of the parallels that they're going to talk about as well. Do you know, latitudes are meant to be parallels, aren't they?
Yes, but it is another contradiction because you can cut sphere into parallel slices.
Mm-hmm.
So you will have parallel planes.
Yep.
So
it's a disproof, right? If you can't have parallels, but you can show that you can have parallels, then that geometry would be disproved. Since we're talking about, we're not talking about a fictitious geometry here. We're talking about reality, supposedly, with this one. You can't play the same games with hyperbolic geometry that you can with Euclidean geometry, right? It wouldn't work. So you can't play those games with spherical geometry and pretend that that spherical geometry is what you're dealing with in reality. You have to make that break or not, one or the other. It gets tricky at this point.
Gauss had long been fascinated by spherical geometry. He was also a geodesist and frequently took measurements of the Earth. In the 1820s, he was tasked with surveying the Kingdom of Hanover to help make a map.
Right, so he's making maps. It's just a normal map on a plane, like all maps are. Made a map.
As part of this survey, he climbed the mountains near Göttingen. With the help of people situated on other landmarks, they were able to carefully measure the angles of several triangles.
Okay.
Oh, so we have measuring angles on the mountain. So this is not geodesic surveyors invention.
No, he's literally making a map and then measuring angles. Several triangles. I'll put the picture up for you so you can have a look. You can see it's just like a traditional map using triangulation. Everybody all right with that? It's just reality. So Gauss did a bit of
which would
geometry.
Then be used to determine the position of one place relative to another.
Mm-hmm.
As a reference for the survey and to help determine the roundness of the Earth, they also precisely measured the angles of a large triangle formed by 3 mountains.
Okay.
He is not going to say that these triangles have had more than 180 degrees, I think.
No, he's not. No, he's going to leave you up to do that, right? So he's just saying, right, here we go.
Position of one place relative to another. As a reference for the survey and to help determine the roundness of the Earth, they also precisely measured the angles of a large triangle formed by 3 mountains. But for all of Gauss's romantic...
Yeah, it's just, they just measured the angles of a triangle. And what do you reckon they got? Any predictions? Any?
But this was made in order to establish roundness of the Earth.
Yeah, but like, what do you think he got with it? Because they're not going to say anything. So they just measured the triangle.
Yes.
Yeah.
I think so.
This is how you know this has been set up by model afflicted people. Because they didn't do it. They left you to make your mind up. What do you think people heard that wanted to have, you know, the dogmaticians? What do you think they heard just right after that? There's nothing there. I didn't hear anything. We'll put it back again. Just let us know. Do you hear anything after this triangle thing?
Roundness of the Earth, they also precisely measured the angles of a large triangle formed by 3 mountains. But for all of Gauss's
No, nothing more.
Nothing.
So he in order to establish or determine roundness of the Earth, he measured triangle. Yes, measured triangle.
He just measured a triangle. Yeah, precisely. Now,
I still don't know how you can establish roundness of the Earth by measuring triangle between hills of. But okay.
Well, Gem
Supposedly
Panda.
we
I
can do
went
that.
to Gem Panda. I've got it on the thing a fair few years ago, and Gem Panda said that those angles have to be more than 180 degrees, and I thought that ridiculous. Right, because triangles have 180 degrees. We went over it with all of the axioms, the way everybody was writing it down. It's even, I know they changed it to the parallel thing, but remember the beginning axiom we call a triangle axiom stated that the triangle will be formed on the side which has less than 102 right angles. That's because the remainder makes the 180 of the triangle. Well, where are we here now? What are we in? We're talking about now. You're meant to be able to place whatever you imagined from whatever model you've got in your mind. You place that number there when it just talked about a triangle that got measured. You did that all on your own. Everybody who heard that, of the 2 million people that have watched the video, they put a number there in that triangle. They did that. How many people do you reckon put 180 whenever they did that? I'd say the majority.
Yeah, I agree. Yeah, but not in this arena. So
Yeah,
this
not
arena
all.
This arena is teaching people that triangles can have more or less. But outside of this arena, nobody would even think that this is just some spherical triangle or whatever.
That is what Gauss said, right? Gauss said, you can tell the surface that you're on by measuring the amount of angles within a triangle. And that will tell you which geometry you should be using. Obviously, in reality, everybody ends up using Euclidean because triangles have 180 degrees. Depends on what number you put in that last bit.
romantic notions of taking measurements on top of mountains, he was not the kindest correspondent. When Bolyai received his hero's response, he was devastated, believing that Gauss was...
See, I don't know whether that was an editing thing or not. Because it doesn't seem to play any part in it about him measuring. It seemed like they were building up to Gauss and some big reveal about it, right? Some proof from Gauss. But it didn't seem to come. It just fizzled out. Maybe an editing mistake. Maybe there was something he was about to put in there or he should have put in there. But other than that, it just seems meaningless, really.
That doesn't follow. This bit doesn't follow from previous statements, let's say.
There seems to be an editing error, doesn't there? Or something just happened there that it doesn't follow. But non sequitur.
Trying to undermine him and steal his ideas. He was so embittered by Gauss's response that he never published again. In 1848, Bolyai had to endure another hardship when he found out that Russian mathematician Nikolai Lobachevsky had independently discovered non-Euclidean geometry, several years before Bolyai had published his 24-page-long appendix. When Bolyai died in 1860, he left behind 20,000 pages of unpublished mathematical manuscripts.
20,000. He put 24 of those into the thing that got sent off to Gauss. But he's got 20,000 pages of Euclidean drawings.
Yeah.
Because that's all of his other stuff was Euclidean drawings too.
Yes, but this was, I suppose, his new universe. So he was drawing his new universe. I think.
Yeah, the ramblings of a madman. I imagine them just posted all over the walls and everywhere, just sort of all over the place. Books, papers, boards, walls, just everything rammed with just drawings of stuff. I don't think anybody could comprehend what any of it meant.
Manuscripts. He would not know that Gauss did independently discover non-Euclidean geometry, nor would he know that upon receiving the appendix, Gauss had written to a friend, "I regard this young geometer Bolyai as a genius of the first order."
That might have been code. You never know. Genius of the first order. I might have to do that. I might have to use that. Sounds good.
Maybe he stole this idea from Bolyai, because as he said before, that he invented supposedly this geometry before Bolyai, even independently. This is what he wrote.
But he was too ashamed to publish it.
Because he was aware that he would be ridiculed. So obviously.
Well, it's strange, right? Because in all of this, Euclid is reality, right? So the proofs within reality obviously could come from anywhere. They existed before Euclid, and they'll exist after Euclid. And it doesn't really matter that Euclid wrote them down. They're still going to be there anyway, right? So anybody can come to the conclusions of Euclidean geometry if you look at it yourself, right? The circle, the square, the triangle, the relationships between them all will always be there, and they'll be findable for anyone, like the flower of life and all of that sort of stuff, the division of cells. It all matches with reality, right? Fibonacci. You'll always get there in the end with Euclidean geometry. Now, what we're talking about here is not that. So I find it strange that Gauss said, yeah, that's what I was doing, because it's a not that. There's no way, I don't think, that you could derive a not that the same as somebody else's not that, unless you're going with spherical and you're having a dogmatic thing that you have to apply, because that's governed by Euclid, right? Anyone can come up with the spherical geometry once you know the boundaries and the rules, right? You're forced into it. It's even more dogmatic than Euclid. Spherical geometry, right? It's entirely dogmatic. But this other one, the hyperbolic, that's just like free-form jazz. Anything that'll go in there. I think that's what he's done. Gauss has just gone, I'll have that. I mean, that sounds like good, doesn't it? How do you derive a not that? The only way you can do it is to talk to somebody, and I think Bulli was probably the only person that Gauss could talk to about it. Except they have no way of communicating with people because their logical system of reasoning's been broke down. So you don't talk to people who can't see contradictions. There's no way to talk to people. They just seem mad.
While Bulli was embittered, non-Euclidean geometries continued to develop. Until 1854, spherical geometry wasn't actually considered a non-Euclidean geometry.
Well, do you know why that is?
Because sphere is a solid object.
Mm-hmm. Sphere is Euclidean.
Geometry.
And it was called spherical trigonometry. It literally was Euclidean. It was using straight lines and shapes within the circle or the sphere. Within 3D. I mean, like, how could it not be Euclidean? But at a certain time, somebody decided, oh, wouldn't it be handy if we pretended it wasn't?
That's because on a sphere, lines can't be extended indefinitely. This is what earlier mathematicians had stumbled upon and therefore dismissed this geometry, since...
So here we go. Okay, they dismissed it because earlier, because they need finite lines.
Yes, but he said now lines, but before he said that great circles are straight lines.
Yeah. Yeah, so, but you're going to see the how they did the final little tweak just to finish it off, to dust it off, to make this non-Euclidean. It's genius.
Euclid's second postulate wouldn't hold. But in 1854, Riemann changed the second postulate from an infinite extension to something that is, quote, unbounded, so that the second postulate still holds on a sphere.
That's clever, isn't it?
Why?
Called it unbounded. That's fucking good.
How can you have circle unbounded?
Well, Riemann did. He just changed the definition of it, and then of the second postulate, no doubt. He didn't change the circle. He changed the definition within the second postulate. Instead of saying infinitely, extended infinitely, it's something about unbounded. That's good, right?
For me, it doesn't make any sense. Oh, okay.
Well, listen to it again, right? Listen to the words that this guy uses, because he's trying to sell this. Somebody's told Veritasium this. He's not made it up. Right, this is what Riemann did in order to make spherical geometry when it was just spherical trigonometry anyway.
Riemann changed the second postulate from an infinite extension to something that is, quote, unbounded.
It's, quote, unbounded. Like, you know what that quote means?
It is not really
unbounded, not really unbounded. So Riemann used a not that bunny ears quote marks in mathematics to change a postulate through the use of words and a bunny ear, not that. Genius. These modern mathematicians, eh? That's how you do it.
So that the second postulate still holds on a sphere. With this change, spherical geometry became another valid non-Euclidean geometry.
So this
that's how easy it is.
So this trick would validate spherical geometry.
Mm-hmm. Remember the beginning bit, how they made new universes and shit. They tweaked one of the other lines, right? And this is, again, Riemann, he's just tweaked another one. Like they're tweaking Euclid to make new geometries. Really, they're exploding the minds of people by doing these little tweaks. But that's modern mathematics. That's where we're at. 2023. Welcome to modern mathematics. They've done mathematics. They've done the number thing, right? They've done the geometry thing. But what they're doing here now, this is fucking about with the logic. They're literally changing words to change the geometry. This is a dilithiaism, call it whatever you want, but it's not traditional logic. Euclid laid it all down. These guys are tweaking it.
By using the generalized four postulates and taking the fifth as there being no parallel lines, you could now derive spherical or elliptic geometry.
Like, this is what gets me, right? Can you just decide how many parallel lines you want to have and flip-flop your geometries around? Or are you governed by reality? Because in certain places, like if you leave yourself governed by reality, then all horizontals are parallel, right? You do have parallel lines. And they're not many different horizontals. You know, there's different lines in different orientations that are parallel. So you can do away with two geometries by just accessing reality. So where do you get these other ones from? How do you decide that there are no parallels? Or there are infinitely many parallels? How does that... Where's the sufficient cause for you deciding there are no parallels? I don't know. Don't think there is. I can't do it. But, you know, other people might say that I'm ignorant of these new fancy geometries or whatever. Because they can imagine no parallels.
Would you consider the fifth postulate a mistake? Would it have been better if he just never wrote that down?
If he never wrote that down, he would have stunted his geometry because he wouldn't be able to prove a lot of things that he claimed to have.
That he claimed to have.
Only claimed. So
like, what's this guy talking about?
He's talking about that Euclid having this postulate. He only claimed
that he
to
made
prove
proofs
that,
from that.
Yes, that he proved things from that postulate. But this is only claim. Maybe really he didn't prove.
Well,
this is what he's saying.
What about, right, that in Proposition 5, Book 1, called the Bridge of Asses, right? And Euclid placed a load of enthymemes within the work, and obviously the triangle axiom was one of the greatest enthymemes I think anybody could ever put. So he puts an enthymeme in a thing that isn't even stated. And then for Proposition 5, he then goes on to say the angles equal at the base of a isosceles triangle, if they extend it, they will still be equal to the proportional. But that also says that the extension of the isosceles triangle, the bases, will always be parallel. But you don't get that enthymeme unless you really look at the Euclid. It's called the Bridge of Asses because I believe that's the part where you derive that. You can enthymeme the parallel lines from the Bridge of Asses, Proposition 5, Book 1. And it's not stated within it. So you can prove parallel lines before you even get to use the triangle axiom within a proof of Euclid. Within it, like, he doesn't even use it until like 30 or 28 or something like that. And he doesn't even need to use it because you've already proved parallels. It's only used for the triangle, but the triangle obviously has to occur as a truth anyway. It's all backwards, but it doesn't prove what they imagine they think it does prove. The actual, I think there's so many conversations to be had about this very thing. And we're only halfway through this video. What time is it? Is it late? But it's late for you as well, Paper, isn't it? Everybody else is
nearly 2 a.m.
We'll have to go over it. I mean, maybe tomorrow or something. I don't know. Maybe Wednesday. We'll have to see when it comes back.
Oh, keep going.
There's only us three. Everybody's left. This fascinates me. This is, like I say, this is what I've been here for. This is logic and geometry. It's got nothing to do with flat Earth or globe Earth or anything, apart from these guys playing their model Affliction, which is what they're going to do. Let me cue up a Buster song. Please come into Discord if you want to discuss any of this. If there's anything that doesn't sound right or anything you'd like to get yourself queued up on, come into Discord, have a word with us. I'll try and explain it. I think we have got the rhetoric down for this, understanding how to explain all of this stuff. So come in, test me out. Let's see whether we can explain it to you. It's not as complicated as it seems, but the being able to see through all of this deceit, obviously, because they're playing about with a lot of stuff, and it probably would be better if you came in to have a look at the stuff. Anybody got any this is where it's all been at. True Level Bitch 23, new one from Buster. Thanks for watching. Should we come back tomorrow? Don't know. I'll see what we can do. If Nathan Oakley's not back tomorrow, I hope he is. But don't forget, send Nathan Oakley some money. He needs it. He needs to get his named PC. Obviously, high-end £5,000 PCs have to have a name. Thank you very much for watching, and we'll be back maybe tomorrow. I love this sort of stuff. Euclid will be going at this over and over.
Hey, Buster, are you there? Have you got your guitar?
Yeah, I've got it right here. I've just been working on something new. It's a song about looking for the truth. Play it for you guys.
What are you doing? I want your shelf level or not? And if I say yes, you're gonna provide that for me with that? Yes? See the bubble? I'm familiar with the bubble, Morty. I also dabble in precision, and if you think you can even approach it with your sad, naked caveman eyeball and a bubble of air, you're the reason this species is a failure, and it makes me angry. You want to experience true level? Do you?
Oh, that's in the mind for all to face.
And it makes me angry.
Choices will be made.
You want to experience true level? Do you?
You can choose to let your mind be free.
Wow, it's so... level.
Everybody knows that you're wrong.
And it makes me angry. Wow, it's so... Oh my God. Oh, Christ. Yeah. True level, bitch.
In the end, you're fine. We're all looking for the truth.
Save it for YouTube. I'll keep looking for clues. Wow, it's so... Oh my God. Oh, Christ. Yeah. True level, bitch.
And that's my midpoint, 981. But look what I did here. And bam, there's the radius of the Earth.
Everything's crooked. Reality is poison. I want to go back. I hate this.
Using this bridge, computing the radius of the Earth, 3 coplanar points in 3D would describe a circle.
You want to experience true level? Do you? True level, bitch. I'll keep looking for clues.
That's the thing, your vision is already being obfuscated by the spherical cap.
One of the humps. Radius of the Earth.
Well, you seem to be in charge of what I get to remember. Why? Good question.
And bam, there's the radius of the Earth.
Yeah. True level, bitch.
Now we have our.
It has been directly measured.
Do you?
Everybody knows that you're wrong.
By Jesse Kozlowski.
You know, I got the idea from Belu. I'm not kidding.
Yeah. True level, bitch. I'll keep looking for clues. Yeah. True level, bitch. Yeah. True level, bitch. Oh my God. Oh, Christ. Yeah. True level, bitch. True level, bitch. All right, save it for YouTube. I'll keep looking for clues.